Guys, welcome back to Lab Cyber, and first of all, my apologies for being away for so long. I've been busy with so many other projects, and then recently I also had to go on a mandatory vacation because I was simply way too exhausted and I needed some rest. But I'm back, and I'm back with a bang, because in today's video, or in today's mega tutorial, you're gonna learn how you can code with Python. And of course, because this is a cybersecurity focused channel, you're gonna learn Python programming for cybersecurity. Now, what exactly does this mean? What this simply means is that the functions, the programs we're gonna build together in this tutorial, they're all going to be cybersecurity related. So together, you're going to build tools like a simple password checker tool, an authentication system, a file encryption and decryption tool, and so on. So the kinds of tools that you would use in real world cybersecurity scenarios, those are the kind of tools we're going to build together in this course. This course is perfect if you've never coded with any kind of programming language before, because it's going to be geared for beginners. And if you're wondering why Python, why not, C# or Ruby or any other programming language out there, we're using Python because Python is one of the easiest languages to learn, especially if you're brand new to the world of programming. And it's also extremely powerful. In fact, the vast majority of cybersecurity tools are typically coded with the use of Python. So what exactly are you going to learn in this 4-hour tutorial? Well, first of all, we're going to cover the very basics of Python. You're going to learn about your data variables, your strings, how you can manipulate strings, how you can splice them, index them, and then we're going to move on to control flow and loops. Together, we're going to learn exactly what loops are, the if-else statements, your do-while statements, and so on. And within this particular module, you're going to build the very first tool, which will be a simple password checker, of course, to determine how strong a user's password is. And then we're going to learn about functions as well. We're going to move on to data structures, where you'll learn about your lists, dictionaries, sets, and so on. And then finally, to round up this tutorial, we're going to build a basic user authentication system. That's why by the end of this tutorial here on YouTube, you'll have learned enough of Python to be able to build yourself a basic user authentication system. Now, like I said earlier, this is going to be about a 4-hour tutorial. It's actually just half of my main course, which you can find on Lab Cyber, my platform where I provide my cybersecurity courses. You can also find it on Udemy as well. I'll have all the links down for you below. But what will you get if you do decide to buy my course? Well, you're going to learn a lot more. You'll learn about file handling. You're going to learn about libraries and modules. You're going to build yourself a file encryption and decryption tool. And then we're going to cover object-oriented programming. And then finally, the mega project, we're going to build an extensive authentication system with a password checker. So if you take this tutorial here on YouTube and you feel like, you know what, I like this course, I want to learn more, you're more than welcome to sign up for my paid course. I will have a special promotion, only $19.99 for the first 100 students who sign up with the coupon. I'll have the links down for you below. Again, you can get it on Lab Cyber, my own personal platform, or on Udemy. You can see 4.5 ratings, almost 700 learners already. It is a pretty good course, I must say. But don't worry, even if you don't want to pay for my course, you're going to learn a lot in this free tutorial. Again, it's over 4 hours. You're going to learn a lot. Now, one final thing I should mention before we begin is that I'm using the Replit platform in here to write my Python code. So if you already have Python installed on your computer, or you use another platform for writing Python code, by all means, you can use those platforms. It is not mandatory that you must also use Replit, okay? So if you have your own preference for platforms or code editors, by all means, you can use them. Now, Replit does have both a paid and a free package. Don't worry, we're going to use the free package. You don't have to pay for anything. So that's it. I sincerely hope you will enjoy this mega tutorial. I'll have, of course, all the timestamps for you below. And of course, the links for the courses if you want to buy them. I'll have everything in the description box below. Thank you so much. Let us now begin to learn how you can code with Python for cybersecurity. Now, in order for you to be able to write your Python code and then test to see how the code works, you're going to need to make use of a platform. Now, there's a wide variety of them out there. We do have Replit and we also have PyCharm. These two, in my humble opinion, are the best. However, for this course, I have decided to go with Replit for two main reasons. The first reason is because I personally believe that it's a little bit easier to use. Trust me, it's a very, very simple to use interface. And then second, even though both are free, Replit is more free than PyCharm. Now, what am I talking about? See, with PyCharm, yes, you can download it. However, you will only be given a 30-day trial. It's only going to last for 30 days and that's it. So unless you decide to go with the premium version, which is about $100, you will no longer be able to use PyCharm. Now with Replit, it's not completely free. The way it works is this, okay? When you sign up for the free account, you will be given a certain package of number of repls and then development time. What exactly am I talking about? See, I'm going to drag, this is my account right here. Don't worry, in the next lesson, I'm going to show you how you can create your account on Replit and install Replit and so on. But don't worry, I want to draw your attention to this, okay? So this is my Replit account right now, and you will see down here, I have the starter plan, which is the free plan, and I have 3 repls, 3 out of 3, and then development time. These two are the most important. What exactly are these? See, whenever you create a Python program, that counts as 1 REPL, okay? And you're given basically 3 opportunities to create 3 different types of Python programs. In all honesty, for the purposes of this course, you're only going to need 1 or 2 at the very most. So 3 is more than enough. Now, the development time is the one I really want to draw your attention to, because right now you can see it says 90% used already. And I have been using this particular account for the past 3 weeks already. So what exactly is this development time? Whenever you open Replit, as it is right now, my Replit program is open. It's already counting as a development time. So as long as your Replit browser is open, you're writing your code, you're running your program, all of these will count towards the development minutes. Now, how many minutes do you have? You have 1,200 minutes. You can see right here, my development time in minutes, I have used 1,080 out of 1,200. So it's 90% used. Now, the good thing about this is that you can manage it properly. So what you want to do is, whenever you're not working with Replit, make sure that you close the browser, close the window. Do not leave it open as it is right now, okay? Do not forget to do this. People very often make that mistake. I've made this mistake so many times already, and it's going to eat into your development time. So once you open up Replit and you're taking the class, you're writing your code, you finish your class for the day, you want to go out, make sure you close your Replit window or tab or browser. Just close it and then you can open it when you're ready to resume the lessons, okay? One other thing I want to mention to you is that with Replit, even if you've used up your development time completely at 100%, by the end of the month, it resets every 30 days. So you can come back after 30 days and then you will have access to your account all over again. Also, obviously, you may not want to wait for 30 whole days. One thing you can simply do is that you can create another account. So hopefully you have more than one email account. So you can create several free accounts with Replit as long as you have the email accounts to actually use to create those accounts. So it's a very, very flexible and a very easy to use platform. And that's why I have decided to go with Replit. So if you have any questions about using Replit or PyCharm, do let me know. I'm going to be here to assist you and help you in any way that I can. So jump in the very next video where I'm going to show you how to install Replit and of course create your account. I'll see you then. All right, so to get started with Replit, pretty easy. Go to replit.com. And of course, you're going to click on sign up for free. And all you'll have to do is to provide your email and your password. And then you log in. And then when you do that, let me drag my other browser in here. On your very first page, you're likely going to see something like this. You'll have to fill out your first name, your last name, and then say it's for personal use. And then you could just simply say none or beginner. And then you click continue. So just as an example, very quickly, let me just do this. All right, Alexander, Oni, personal use, beginner, continue. And you want to go with the free package. Click on continue with starter, and you should be good to go. By the way, you will get an email asking you to verify your email address. So go to your email account and make sure that you verify your email address. All right, so now that you have access to Replit, by the way, I might call Replit REPL many times in this course, so please just be aware of that. This is going to be the home page, and in order to create a REPL for Python, you can simply click on the Create Python button right here. Now, if you don't see Create Python, simply go to Create REPL. All right, and then in here you will see Python, and then simply click on Python and then create the REPL, and then you will have access to this. So I'm going to go ahead right now and click on Create Python, and let's just add a title. So I'm going to call this one Lesson 1, just as an example, okay? And then I'm going to click on Create REPL. So right now, this has taken us to the main page where we can begin to add code for our particular program. So this is the main work area right here. And then on the right, you'll see we have access to the AI window, the console, as well as the shell. Now, AI, of course, this is something new that's been added. We will be working mostly with the console where we can run our code, and also the shell terminal. And then over here on the left, notice that our file is actually called main.py. This is typically the default title that Replit will give your main program. If you wanted to create a new file, we'll simply come over here, click in there, and for example, I can call this one test.py. Okay, and just like that, we have another window for another program. But I'm going to go back to my main.py. And then down in here, we have access to different kinds of tools, such as the console, the debugger, the output, and so on. We're going to take a look at a few of them later on in this particular course. But now I want us to write our very first program. So over here in the main window, I'm going to type the words print, which is of course a command. And as you might have guessed, print simply means we want Python to display something. Okay, so notice also that Replit automatically will begin to provide different kinds of ways of using that particular command. So kind of like helpful hints. But I'm just going to add my open and closed brackets and then double quotes. And then I'm going to say hello world. Okay. And now over here, I'm going to go to the console window, and then I'm going to click on the run button. And now just like that, we have our very first program printing out the words hello world. All right, so don't worry if all of this is a little bit overwhelming. We're going to be working with Replit throughout this course, so you will get accustomed to all the functionality, the windows, and so on. However, there's two main shortcuts I want you to be aware of. If you are on the Mac, it's going to be Command K. If you're in Windows, it's going to be Control K. Now, when you do that, this will bring you to the search bar where you can very quickly type in whatever it is that you want to search or you want to run. And then also, if you wanted to run the command, instead of having to click on the run button in here, you can simply use Command Enter on your Mac or Control Enter on your Windows, and Replit will automatically run the program for you. You do have additional buttons in here, like you can split the plane if you wanted to, if you're writing more than one particular program at a time. You can maximize your panel as well if you wanted to, or you can, of course, restore the panel, things like that. Let me just go ahead and close this tab and go back to the default settings. So that's pretty much it for the introduction to Replit. Thank you for watching. I will see you in the next class. Welcome to lesson 2, and previously we successfully created our very first program that printed the words hello world. Now, I wanted to use this opportunity to really break this program down and help you understand what exactly we did, because I'm going to assume it's your first ever program and you're new to the world of programming. So right here, we initiated the command called print. Now, print is a function. With Python, you have inbuilt functions that will do something for you. Print is one of such functions that will, of course, print out whatever it is that we tell it to print. Now, notice that we do have the parentheses, okay, opened up, and typically whenever you're working with functions with Python, you will have the name of the function, and then you're going to have parentheses, which are the brackets. And inside of the parentheses, you're going to have something that we call a variable, okay? Variables are kind of like inputs or data that we give to the function to work with, okay? In this case right now, the variable is the text hello world. Now, we're letting Python know that hello world is text. It's a string format. Don't worry, we're going to talk a bit more about data types a bit later. But in order for Python to understand that hello world is actually a piece of text, we wrapped it in double quotation marks, as you can see. That's why Python knows that, oh, these aren't numbers. This is not some sort of a calculation. These are just letters, words that need to be printed out. That's why we wrap them in quotation marks. Now, if I was to come over here right now and typed in something, just, something random, notice it's of course outside of the quotation marks, okay? If I was to go ahead right now and run my program, you will see right now that it displays an error because the syntax isn't correct. If you're going to display anything using Python and the print function, it needs to be in quotation marks. So this isn't going to work. Let me go back, add my double quotation again, run, and we're back. Okay. What if I wanted to print hello world, let's say 5 times, okay? Now, I could do this, okay? I could simply just copy and then come over here, paste, 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 paste. And then if I was to run, you can see right now it will print out hello world 5 times. Pretty straightforward. Okay, let me just go ahead and remove the 4 additional lines. I want to show you a different way, okay? We could do something like this, okay? I am going to create something that I've mentioned before, and that's a variable, okay? Variables, again, they're like inputs that we can use to store data. Now, I'm going to call this variable, let's say text, okay? Let's call it text1, okay? That's the name of my variable, and I'm going to say it's equal to, and now in double quotation marks, hello world, okay? So what I've done right now is I have simply said I'm going to add the text hello world to the variable text1. So text1, the variable text1 is now holding, it has the value of hello world. Now check this out, okay? I'm going to go over here right now to my print function, remove the text, the string, and I'm simply going to say text1. Because again, text1 is equal to hello world. And now I'm going to run my command, and there it is. We have hello world. And of course, I could simply copy this once again, and then I could paste, 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 run the command, and take a look at that. All of a sudden, we have an issue. Why? Well, that's because Python reads print text1, and then again, immediately it sees another print text1, print text1, print text1. That confuses Python. So what you want to do right now is we want to add these in separate lines. It's typically very good programming syntax. If you're going to run more than one function, you want to run them in separate lines. You should never run multiple functions within the same line. So I'm going to go back in here, click on run, and there it is. Everything is back to normal. So that's just a very small snippet of what we're going to be dealing with. Obviously, we're going to be dealing with far more advanced functions and programs, but step by step, we're going to get there. So hopefully you now understand a bit better what variables are, functions, and how the syntax for Python works. Thank you for watching. I will see you in the next class. All right, so welcome officially to the very first main section in the actual Python course itself. And in here, we're going to be talking about variables and data types. Listen, I guarantee you that regardless of what programming language you're trying to learn, this typically is going to be the very first section, because at the heart of every program, no matter how basic or advanced it is, it's going to revolve around some piece of data, whether it's strings or integers. You're going to have data involved in every program. So in this section, we're going to talk about the different types of data out there. We're also going to talk about the Boolean operations. So say, for example, you wanted to say something isn't true or something is false, stuff like that. And then, of course, the arithmetic operators, okay? How do you add, subtract, multiply, divide in Python? Basic math, right? We're going to learn all of that in this section. And then, of course, at the end of the section, there's going to be a coding exercise, which I want you to attempt. Give it your all. Don't worry if you're unable to solve it. I will provide you with the solution as well. So, congratulations, we're about to begin our journey into the world of Python. Let's begin. Welcome back. Now, let's spend a bit more time to talk about strings. So far, we've worked with the hello world string, and I did say that whenever you're wrapping your text, you typically want to use double quotation marks. However, that's not always true. All right, the default is to wrap your text with double quotation marks. However, you can actually get away by using single quotation marks. So let me just go over here right now and edit that. I'm using single quotation marks. I press run, and you can see it works perfectly fine. So you don't always have to use double quotation marks. The natural question you might have here is, okay, so when do we use single? When do we use double? Does it really matter? In most cases, it really comes down to your personal preference, whether you are a single quotation user or a double quotation user. The default, most programmers tend to go with the double quotations. And there are instances where you could actually even use both of them in the same string. As an example, what if I wanted to say something like, he said hello, right? So let me just go over here right now and say, he said, comma, and I'm going to say hello. How would we be able to print this out successfully? Because if we clicked run right now, it's going to give us an error message, okay? We need to wrap these text, these letters in quotation marks. But how do we go about it? Well, we could do this. I could go over here right now, add a single quotation mark. Oh, sorry. It has to be inside. So the single quotation mark first, okay? And now for the actual words that he said, hello, I'm going to use the double quotation marks in here to wrap the exact word hello itself. And then whenever, actually this is pretty common in programming languages, okay? Whenever you have like an opening quotation mark, you want to have a closing quotation mark as well. So I'm going to add the single quotation mark right there. And now if I click run, you can see right now it actually works. We could do the exact opposite. I could start off with a double quotation mark, okay? And then I'm going to come over here right now, wrap hello in the single quotation marks, and then add the closing double quotation marks, run, and you can see it works perfectly fine. However, what if I wanted very long strings, right? So I do have my lorem ipsum generator in here. So let me just grab this first paragraph over here, okay? Copy, come over here. Now, I could actually wrap everything as big as it is inside of the double quotation marks, click run, and it's going to work perfectly fine. But what if I actually wanted to create some space? And so, for example, I wanted to have some space in here. I come over here right now and add some space in, right? Now it's all kind of disorganized. I click run, and now we're going to have an error message. It's not working anymore because Python cannot understand the space in between the lines of text. So this is where the triple quotation marks will come in. So watch this, okay? I'm going to add 1, 2, 3. Okay. Oops, sorry about that. That is 3. Okay. And of course, I'm going to come over here right now and add the closing 3 quotation marks. And now if I click run, and there you go. You can see it actually works. So there are certain instances where you may want to use triple quotation marks if you have very specific kind of spacing. It's also typically used for like documentation, writing lines of code, things like that. That's where you would use the triple quotation marks. Now, we could also combine strings. All right, so as an example, let me quickly show you. Let me create a new variable here and say x, okay, equals, and then in double quotation marks, I'm going to say hello. Okay, and then I could create a second variable, y equals world. Okay, and now if I wanted to combine both of them, I could say print, in parentheses, very simply, x plus y. And now if I click run, there you go, hello world. But if we wanted to add the space between hello and world, all I can do is I can either add the space at hello right here. So I've added the space after the O, click on run, you have hello world. Or I could do the opposite and simply add the space at the beginning of W, click on run, and there you go, you have the exact same result. Now let's make this just a little bit more sophisticated, this program just a little bit more sophisticated. I'm going to introduce to you a new function called input. So far we've been working with print. Now let me introduce to you input. So input is basically a function that will ask the user to provide something. Okay, so I'm going to say input, and then in parentheses, I'm going to say something please. Okay, so if I run, sorry about that. If I run the command, you can see right now it says say something please, and now if I say hi, my name is Alex, and I press enter, nothing happens. Okay, because our program, all it does is to ask the user to say something, and that's it. It's not going to do anything with what the user has actually said. So to make this a little bit more advanced, I'm going to go back in here. Okay, let's remove this and let's create a new variable. I will say user response. Okay, this is going to be the name of my variable. And by the way, let me just say something real quick. It's good etiquette, good programming etiquette, whenever you're creating names for your variables or your functions and you're combining two words together. In this case right now, I'm combining user and response. The second word, the first letter typically should be in capital letters. That's why the R for response here is in capital. I'm just saying, okay? So just, bear that in mind. So user response equals, okay? And I'm going to say input, and now in brackets I'm going to say say something please. Okay, however, I'm going to come down here. I'm going to now use the print function, in brackets, I'm going to say user response. That's it. Pretty straightforward. I'm going to go ahead right now, run the command. It says, say something, please. So I'm going to say, my name is Alex. Press enter, and there you go. Now it's saying, my name is Alex. So successfully introduced to you a new function, which is input, which will ask the user to provide something. We've talked about how to use the single quotation marks, the double quotation marks, as well as the triple quotation marks. And I've also shown you how we can actually combine strings by creating multiple variables and simply using the plus operator to combine them. So gradually, we're getting better and better at working with Python and strings. So thank you for watching the video. And of course, I will see you in the next class. Let's now take a look at a different form of data type. So far, we've been working with strings, right? But now let's take a look at floating points and integers, otherwise simply known as numbers. All right, so let's go ahead and remove this program. And let me first of all create a variable x equals to 4. Okay, and then y equals let's say 6.0. Now, the obvious difference between these two is that x doesn't have any decimal point. Y does. Y has the 6.0. All right. In fact, let me make this a bit more reasonable. Let's make it 6.3, just as an example, right? So y in this case would be a floating point because it does have a decimal point, while 4 will be the integer. So if I went ahead right now and I printed x plus y and I run my program, you can see we're going to get a number 10.3. Pretty straightforward, right? However, we could do certain things like, say, for example, if you wanted to convert 10.3 being a floating number, if you wanted to convert it to an integer, we could simply use a new function called the integer function. So what I'm going to do right here is inside of this first bracket, I'm going to open up another bracket and add int. All right, so int, sorry about that, int. Okay, so int here is a function that stands for integer, all right? And of course, since we've opened the integer function, we're going to have to close it as well. So let me add the closing bracket. And now if I was to run my program, you can see it has converted 10.3 to 10 because of the function int, integer. So this was the first time that we've added a function inside of another function. First, we have the print function, and then inside of the print function, we have the integer function. So this is one thing you should be aware of when it comes to Python programming. You can have a function inside of another function, and in fact, you can have 3-4 functions instead of one another, just as long as the hierarchy is correct. In this case right now, I cannot have the integer function come in first and then print. In fact, you know what? Let's try it, okay? Why not? I'm going to go ahead right now, print, okay? And then int, okay? What's going to happen? I'm going to click on run, and there you go. So even though it it didn't really work. I mean, we did get the x plus y. We did get the correct answer to be 10.3, but unfortunately, it didn't convert the results to an actual integer. So Python basically ignored the very first part, which is the integer function, and then just went ahead and said, okay, print x plus y. And then, of course, it told us that, hey, there's some sort of an issue with the syntax. So you have to be careful whenever you're trying to add functions inside of another function. There needs to be a hierarchy, and it needs to be correct. So let's reverse that, run again, and there you go. So likewise, if I wanted to convert the result to a floating number, I could do so as well. So for example, right, if I change the y here to, let's say, 5, right? But instead of 9, which would be the obvious answer here, I wanted it to be 9.0. I will change the integer function in here to float. So this is the opposite, right? So check this out. I'm going to click on run, and there you go. It is now 9.0. It's, there's a good chance you may not need to use the integer or float function in your programs. It all depends on the kind of programs you will create. But nevertheless, it's important to understand these concepts that you can add. You can convert one data type to another, and that you can also have one function inside of another. So thank you for watching. I will see you in the next class. One more type of data type you should be aware of will be the Boolean operations or the Boolean values. Typically, it's going to be two of them. You either have true or false, and it will depend largely on the outcome of certain kinds of operations. Now, as an example, over here, I have the variable x equals 5, the variable y equals 10. Now, I have my very first print function in here that says x is equal to y. The second is x is less than y. So with Booleans, you either have true or false. Now, what do you think the answer for the very first print would be? Well, the answer obviously would be false because 5 is not equal to 10, while the second should be true because x is in fact less than y. So now if I go ahead and run this program, now you can see we have false and true. These are what we refer to as the Boolean values or the Boolean operators. And we typically use them whenever we're trying to create loops or conditional statements. Don't worry, we're going to talk about those in the next section. But typically, we may want to write a program that will check to see if something has happened. And then if it has happened, meaning if it's true, then do something. Or we can also say, if this thing hasn't happened, therefore, if it is false, then do something else. So we're going to be making use of Boolean operators and values a bit later. But the thing about Boolean values and operations is that they work with the comparison operators like your equals to, less than, is equal to, and so on. But we also have what we call the logical operators. Logical operators will be things like and, or not. So as an example, let me give you another program in here. Let me first of all say A equals true, okay? And then B equals false. By the way, please note that the true and false here are not strings. And they're not strings because you can see that with true, it starts with a capital T, and with the false, it starts with a capital F. So Python automatically knows that, okay, you're dealing with Booleans in here. So if I wanted to write a print function in here that says something like, let's say, A and B, let me write another one, print, let's say, A or B, and then the last one, print, and I'm going to say, let's say, not A. What do you think the answers will be for this three? Typically, whenever you're dealing with the logical operators and you're comparing two or more values, all of them will need to be true whenever you're using the AND statement. If one of them is false, then the answer will be false, okay? The opposite is with OR. So if you're saying true or false, it's going to be true. If it's true and false, the answer will be false. And then obviously for the last one in here, not A will be false because not A means the opposite of true. Opposite of true is false. So if I run the program right now, you will see once again that A and B, true and false, will always be false, while true or false will be true, while not A will be false. So once again, Boolean operators and values, they work with logical operators as well, such as your and, or not. And of course, your comparison operators such as your equals to, or is not equal to, less than, greater than, and so on.
So we're going to be working with Boolean operators as we progress in the course. Thank you for watching. I will see you in the next class.
Let's talk about some more operators, and starting off with the arithmetic operations. And this is just like, you know, the mathematics or basic mathematics that we learned back when we were kids, right? So you have, 1 times 1, 2 times 2, 3 plus 1, 10 minus 7, that kind of thing, right? So what I've done here is I've assigned the value of 10 to variable A and the value of 3 to variable B. And I've written out several arithmetic operations in here. We have A plus B, A minus B, A times B, A divided by B, A modulus B, which will simply return the remainder when we divide A by B. And then the last one here is going to be A exponential B, which will raise the value of A by the power of B. So what are the results here going to be? Let me run the program, and of course 10 plus 3 is 13, 10 minus 3 is 7, 10 times 3 is 30, 10 divided by 3 will be 3.3333, and then 10 modulus 3 will be 1, and of course 10 times 10 times 10 will be equal to 1,000, right? Okay, so I expect that you obviously knew the answers to all of these operations. But let's go further. I'm going to remove this, okay? And I do have some more operations in here. And the first one in here is what we call an assignment operator. You can see right there, it says plus equals, right? Let me add this in new lines. And there you go. Okay, so we have plus equals. What this simply means is that we are going to say x equals x plus 5. It's basically the same thing. So x plus equals 5 is the exact same thing as saying x equals x plus 5. This is just a short form of writing this. So let me just go ahead and remove this. So what do you think the answer here will be? The answer obviously here is going to be 15, because 10 plus 5 equals 15. Now you can do the opposite, okay? You can say minus and then equals. The answer here obviously would be 5, because 10 minus 5 will be 5. And you have other ones, of course, like the multiplication, which will give us 50. And then we also have the division, which will give us 2.0. So these are what we call the assignment operators. Now, I want to draw your attention to one more thing, and this is what we call the operator precedence. Let me first of all remove the code, and let me drag this to the top and print on a new line. Let me copy this command and come down here and then print. All right, so take a look at this. Okay, we have two different expressions. All right, the first one here says 2 plus 3 times 4, while the second one here is we have our brackets 2 plus 3 and then times 4. What do you think the results of both expressions are going to be? Again, this might remind you of the math that you did back in your kindergarten or primary school days. But I always find this thing rather fascinating, right? Because here we're going to get two different results. So you can pause the video and try to guess what the results of both expressions would be. If you have your results, let's go ahead right now and run. And the first one here will be 14, while the second will be 20. Why? Because on the first expression in here, we have two operators, right? We have the plus arithmetic operator, and then we have the multiplication. Python will do the multiplication first before the addition. So 3 times 4 is going to be 12. 12 plus 2 is going to be equal to 14. However, over here in the second expression, it's actually going to do the addition first because they're inside of brackets. That's why. So unless I'm mistaken, typically it is, you will have the parentheses will be at the very top of the precedence. If you don't have the parentheses, it will check for exponentiation. If there isn't any exponentiation, then it will go to multiplication, it will go to division, it will go to modulus, addition, and then finally subtraction. And then in a very complex expression, if you do have comparison operators, those will come next. And then finally, logical operators. But no need to go any further than that. Over here, we simply have two main operators, or rather we have three. We have the parentheses, which of course will take precedence over the multiplication. So 2 plus 3 is 5. 5 multiplied by 4 equals 20. So once again, this is what we call the operator precedence. Again, to be honest, we're not really going to be working with these in this course, but nevertheless, this is something that you should be aware of. Thank you for watching. I will see you in the next class. All right, so welcome to the very next section where we're now going to focus specifically on the strings data type. I know previously we talked about strings already. However, we need to delve even deeper into this particular topic. And why? Well, that's because the vast majority of time, the data type you will be working with are going to be strings. Yes, you will work with integers and other data types, but strings typically will be about 80 to 90% of the types of data you work with. So in this section, we're going to delve a lot deeper. I'm going to show you how you can manipulate strings. So say, for example, you have two pieces of string. You want to extract certain letters from the string. You want to extract letters from that other string, join them together, things like that. You will learn how to do such things. You're going to learn how you can convert entire strings to uppercase or lowercase, how you can slice them and do so many other things. So I believe you're going to enjoy this section. And also, just like with the first section, by the end of this section, there's going to be a coding exercise as well. So please do attempt the coding exercise. Hopefully you will be able to successfully do it. But if you can't, I'm going to provide for you the solution as well, so you can compare your code with my code. So without wasting any more time, let's begin. So you're already familiar with the different ways of printing out your string variables. What I have on my screen right here, I created the variable username and assigned the value of cyber as a string to it. And then I simply said print username. That of course resulted in printing out cyber. Very, very simple, very basic. And now from line 4, I assigned the exact same value cyber to the variable username. But notice that on line 5 and 6, I demonstrate two different ways of printing out the variable. I could have said, welcome to the world of programming, and then comma, and then the name of the variable, which is of course username, cyber, and the output is welcome to the world of programming, cyber. And then on line 6, instead of using the comma sign, I use the plus symbol. And this basically is what we call concatenation. Whenever you're using the plus symbol, and then you have the exact same output. However, notice that there is a slight difference in the spacing. With the comma symbol, you tend to have a bit more spacing between your string and then the actual name of your variable. Nevertheless, both methods work pretty well. It's all a matter of choice. However, let me show you a few other basic ways of manipulating your string. So say, for example, I wanted to print cyber 10 times, right? Instead of me creating username cyber, username cyber, username cyber 10 times, what I could simply do right here is I could just add the asterisk symbol and then just say times 10. And then all I have to do right now is just to simply print the username. And now if I run the program, you can see we have cyber, 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 cyber 10 times. And if I wanted space in between my words, I can just add a space between the R letter and the closing quote. And if I run the program again, there you go, we have cyber, cyber, cyber. So this is what we call repetition, right? One other function I wanted to let you know regarding strings is the length of a string. We can determine how long a string is. Basically, in other words, we can determine the number of characters in a string. So, for example, over here, if I wanted to figure out how many characters were in cyber, all I have to do is to come over here. After the print function, I can introduce another function called the length function, which is of course len, and then I will have to add my closing bracket right there. And now if I run the program, can you guess what the value is going to be? the value is going to be 5, because cyber is made up of 5 characters, 5 letters. Now you might be wondering, okay, this is all good, but how is this relevant? How do we apply this in the world of cybersecurity specifically? I'm pretty sure you must have seen on websites before where they ask you to log in, you begin to type in your password, but then you don't see the actual characters. Instead, you might see like the dash symbol, or most commonly the asterisk symbol in their place. We can use the knowledge we've gained so far to actually recreate a similar scenario. So check this out, okay? I'm going to create a new variable right now and call it password. And now let's add the actual password. I'm going to say swordfish, which isn't exactly the best password, but never mind. We're going to go with swordfish. So now I want to print out swordfish. So I can just say print password, right? So if I run the program, it's going to say swordfish. But we want to replace each letter in swordfish with the asterisk symbol. So basically, we should have 9 asterisk symbols in place of the actual letters themselves. So what do? I can create another variable right now and call it the masked underscore password. And now this will be equal to what? I'm going to add my quotes and now add the asterisk symbol. Okay, the asterisk symbol, and now multiply it again by the length of the characters of our password string. And there it is. So now, if I run the program and that did not work, oh, do forgive me. For the print password, we need to change line 3 here to masked password because we're no longer printing out the password. Oops, that was a bit embarrassing. Okay, so we're going to print out the masked password now. And if I run the program, there you go. Okay, so now we have 9 asterisk symbols because swordfish itself is made up of 9 letters. And just to prove to you that this actually works, if I added 3 more characters, digits in this case right now, 1, 2, 3, and I run it again, now you can see the number of asterisk symbols has increased by 3. Instead of 9, it is now 12. So this is how you could recreate something very similar in your real world program. If you wanted to create a masked password system, you can use these kinds of concepts. So thank you for watching the video. I will see you in the next class. Welcome back. Now let's talk about some very important concepts when it comes to dealing with strings. We do have the concept of indexing. Now, don't worry, we're going to talk about indexing a lot more later on, but now let me give you sort of a brief introduction, right? Say, for example, over here, I do have my text, which is equal to cybersecurity. Now, what if we specifically wanted to, for one reason or the other, extract the very first letter in the word cybersecurity? The first letter here would be C, right? So I could do something like, say, first and then underscore character equals to text. And now I'm going to use my brackets. And now I need to indicate the index position of the letter I want to target. Now in cybersecurity, C is the first letter. So what do you think my index number here is going to be? Nope, it's not 1, it's going to be 0. Please keep in mind that in programming in general, not just Python, but general programming, your indexing starts from 0 and not 1. So if I now wanted to print out the contents of my variable called first character, the answer here is going to be capital C. Likewise, if I change this one to 1, now it's going to be Y. So this right here is indexing, and we're going to be working with it throughout this course. Now, the second concept here is going to be the concept of slicing. Slicing allows us to take a portion of the string. Now, cybersecurity is a pretty long string. So what if we only wanted to target like the very first 5 characters, which would be cyber? How would we do this? Well, in here, I can add my index position for the very first character, that's going to be 0. And then where do I want to stop? 5. This right here is what we refer to as slicing. The very first number in here represents where we want to start the slicing from. In this case right now, I've added 0 because I wanted to start from the very first letter. And then how many characters do we want? We want the 5 characters. So now if I run the program, it's going to be cyber. Now, what if we wanted to extract security only, right? We don't want to target cyber. We want to target security only. One thing I could do here is that I could decide to simply go with the index number of capital S, which will be 0, 1, 2, 3, 4, 5. Okay, it could be 5. And now I add my colon. I could indicate how many letters I want the slicing to contain. However, if I don't indicate a value in here, Python will automatically default to the end of the string. So now if I run the program, it's going to say security. Did you see how that worked? I indicated, okay, I want to start from capital S, and the index number of S here is going to be 5. And because I did not indicate where I want the slicing to stop, Python will just go until the very end. That's why we have security. Likewise, I could do almost the opposite. I could leave the start empty, and now I could go over here, and if I indicated, let's say 5 as an example, what do you think the value here is going to be? When you don't indicate your start position, Python will automatically start, the default position will be at the very beginning. So what do you think the answer here is going to be? The answer here is going to be cyber. Because even though we didn't indicate the beginning, Python will default to the very beginning, which is C, and then 5 characters is going to be CYBER, and that's going to be cyber. However, that's not all. We could also use the concept of negative indices. So, for example, check this out, okay? I'm going to go over here, all right? And if I wanted to target security, one thing I could do is I can start from the end, and I know that security is what? It's 8 characters, so I'm going to say -8. And now I'm going to add my colon and default to the very end. And now if I run the program, there you go, it is security because Python will start from the end, which is Y, and then it's going to go 8 letters to the left. It stops at S because S is the 8th letter, is the 8th character when you're starting from the end. That's why we have security as the answer. You might be wondering, okay, how will this be applicable to cybersecurity? Have you ever wondered how anti-malware and antiviruses are able to scan and detect malware? Typically, the file extension will have .exe. So, for example, if our file name equaled to cmd iop, something weird, right? And then .exe. This would be an example of the typical kind of malware file name that you will have. So how can we write a program that will scan and then detect, as soon as it detects the .exe extension, it knows that, okay, this could potentially be a malware. We haven't talked about the if statement yet. We're going to talk about it in the next section, but just assume right now that, okay, if the file name, okay, and now if I added in brackets, if I wanted to target the .exe from the end, because we never know how long the file name is going to be before the .exe, right? It's always better to target from the end. I know that -4, starting from the end, if it's equal to what? .exe. If I know that the last 4 characters in the file name is equal to .exe, then I know that most likely this is going to be a malware. So now I can just simply say print and then in brackets, I can say malware found, something like this. So this is how the concept of slicing can be applied in the world of cybersecurity. Now, before I round up this video, let me talk to you about one more function that is useful when it comes to working with strings, and that's going to be the split function. It is a function that will break a string into a list of substrings based on a specified delimiter. What am I talking about? Say, for example, I go back to my text and it equals to cybersecurity. Now you can see it's two words, right? It's no longer just one single word, cybersecurity. Now I've got two words, cybersecurity. So if I wanted to split this, I can say words, all right, equals text and now dot split, okay? I'm attaching the split function to the variable text because I want to split cybersecurity. So now if I simply printed the words, what do you think the output is going to be? It is going to be cyber and then security. And if you're wondering, okay, how are we going to apply this in cybersecurity? Jump in the very next video where we'll begin to take a look at cybersecurity applications of slicing, splitting, and so much more. Welcome back. So let's continue talking about the different types of methods or functions that we typically apply on strings. And one very common one, in fact, two very common ones rather, would be the functions for converting text either to uppercase or lowercase. So in my example over here, I have my variable text equal to cybersecurity. If I wanted to convert everything to uppercase, I would simply say text and now dot upper, open up new brackets, and there it is. And if I wanted to convert everything to lowercase, I'll do the exact opposite. This will be print text dot lower, open up new brackets, and there it is. So if I run the program right now, you can see we have cybersecurity in capital letters and then cybersecurity in lowercase letters. So these are two new functions you should be aware of, dot upper, dot lower. But there's also the function for trimming white space. So say, for example, I have my password variable in here. I've got space and my actual password is swordfish, and then let me add some more space. If I wanted to trim all the unnecessary white space in here, all I would do is I would say print brackets and then password and now strip. Once again, the strip function, we can also use it to remove any unnecessary white space. Run the program, and there you go, swordfish without the empty space. But we can also replace characters in our strings. Say, for example, let me just give you one example in here. Let's say I've got my message being equal to, and let's say, okay, user password, okay, and let's say the password right now is password 123, okay, just as an example, right? But then we wanted to print something that will say, okay, user password and then redacted, okay? We don't want to display the actual password itself. It's similar to what we did in the previous lesson where we used the asterisk symbol to replace the characters. It's related but slightly different. So let me show you what I'm talking about, okay? So I'm going to come over here right now and I'm going to say, let's create a new variable. Let's say secure underscore message, okay, will be equal to now message dot and now a new function called replace, okay? I want to replace the actual password with something else. So inside of my brackets, I am now going to put the actual password I want to replace, which is password 123, comma, and now the actual letters or characters or string I want to replace it with. In this case right now, I'm going to open up my brackets, and in capital letters, I can say redacted. Just as an example, okay? So now all I need to do is to simply print in brackets secure underscore message, And now if I run my program, there you go, user password redacted. So you can use the replace function to simply replace any particular part of your string with something else. And this is how you will do it. To round up, let me show you one more thing, and this is finding substrings. Say, for example, we have a variable called email, and it's equal to, let's say, admin@labcyber.com. I'm pretty sure, of course, you must have encountered this so many times before, where maybe you're trying to create a new account on a website, and they will ask you to provide an email address. If you typed in something bogus, for example, the system will be able to detect that, hey, this isn't a valid email address. And that's because it could check to see if the @ symbol was included in your input. So if the @ symbol isn't there, then obviously it knows, okay, whatever this person typed in cannot be an email address. So let me show you how we can write a very simple program to check to see if the @ symbol is in the string. So from here, I have my email equals admin@labcyber.com. Let's check to see if the @ symbol is in it. Okay, I'm gonna say if. Okay, if. I know we haven't talked about this particular if statement yet. Don't worry, we'll cover it in a lot more detail in the next section. But for now, just know that if is a statement that Python uses to check if something is true. So I'm gonna say if, and now email, and then dot find. This is the function that we can use to check to see if something exists in our string. So that's the find function. And now we have to specify what exactly are we looking for in brackets, and now in quotes, the @ symbol. So we're trying to check to see if the @ symbol exists. And one way how we can verify that indeed it does exist, it is in our string, is by saying it is not equal to -1, and then we add our colon. So this not equals to -1 is a way of saying, okay, something does exist. Okay, so right here, we're saying if in the email you found the @ symbol and it's not equal to -1. So this confirms that yes, indeed, the @ symbol is in our string. So now we can do something. We can say print, and now in brackets, we can say valid email format. So now if I run my program, there you go, valid email format, because the @ symbol was in fact found. If I remove the @ symbol, and now I run the program again, you can see nothing is printed out because the @ symbol is no longer there. It is not a valid email format. I go back, I add the @ symbol again, I run, and now you can see it's working again. So to give you a quick recap, first of all, we want to look for the @ symbol in an email address provided to us. So we're going to say if, and then we're looking specifically for the @ symbol. So if the @ symbol is present, and we check to see if it's present with the not equals to -1. So if the @ symbol is in fact present, simply print valid email format. So take note of the find function. So that's it for the video. Thank you for watching. I will see you in the next class. Welcome back. So let me walk you through a few more operations by making use of the split function as well as some good old indexing. So I have on my screen two notes. I have an email address and then also a URL. Now looking at the email address, what if we wanted to extract the domain specifically? So we wanted to extract labcyber.com and just get rid of the admin @. How are we going to do this? Well, first of all, let's assign a variable email to be admin@labcyber.com. Okay, so what I'll do right now is I'm going to create another variable that will now hold what we're looking for. So I'm going to call that one domain. And now this is where the magic happens, okay? We want to split our string. We want to separate admin from labcyber.com, right? So in between admin and labcyber.com is what is the @ symbol. So I'm going to say email and now split, and now in brackets, where are we going to split from? We're going to split from the @ symbol, okay? And now because we're looking for the second element, when you split admin at labcyber.com from the @ one part will be admin, the other part will be labcyber.com, right? So we want to go with the second element, and that's going to be 1. 1 will stand for labcyber.com. And now all we have to do is to simply print our domain. And if I run the program, there it is, labcyber.com. If I changed 1 to 0 instead, this will now represent the first element, which is going to be admin. So if I run the program again right now, you can see it has changed to admin. So whenever you're trying to split a string into 2 using the split function, first of all, you want to indicate, okay, where do you want to begin the split from? In this case right now, we said from the @ symbol. So right down at the middle, on the left will be the index value of 0. On the right will be the index value of 1. And since we're looking for the domain specifically, we change 0 to 1. We run again. And there you go. We have labcyber.com. Now, what of the second example in here, the URL? What exactly are we looking for here? Let's say we wanted to extract the actual file itself. So we're not interested in the whole https labcyber.com/path/to. All we're looking for is simply the file name. How can we extract file from this? So what I'm going to do very simply is to say URL equals, and let me just grab this. Let me just copy that, and I'm going to paste it. And there you go. Okay. So again, I'm going to create a new variable that will now hold the value of what we're looking for. Let's call this one the file_name. Will now be equal to URL, right? And now dot split. And now check this out. Looking at the URL, okay, this full URL, what do you think, what symbol do you think we could use to split the string into multiple parts? Yep, it should be obvious. It's going to be the /, right? Because you can see right there, it's everywhere. So we're going to split our string. We're going to split our URL using the /. And now, how can we target the file? Do you remember negative indexing? Where we start from the end of our string. So in this case right now, what are we looking for? We're looking for the very first element from the end, and now that will be negative what? -1. So it's going to start from file, it's going to start from right to the left, right? So now all we have to do is to simply print the file_name. And this should do the trick. Let's go ahead and run the program. And there you go. We have the file name. So by making use of the split function and also a negative indexing, we were able to specifically target the file name. Let me give you one more example. And here we're going to extract some strings without using the split function. We're just going to use the index values. So let me provide the email address again. And I'm going to say admin@labcyber.com. And okay, so what if we wanted to extract both the username and the domain? So we want to extract the username, which is admin, and then the domain, which is labcyber.com. How do you think we can do this? Well, first of all, I can say my username is going to be equal to email. And now remember how the indexes work when you have your start and then the end. So we want to start from the very beginning of our string. So we're going to say colon. We're going to leave the left side blank because we want to start from the very beginning. And now let us see. A is going to be index number 0, right? So A is 0, D is 1, M is 2, I is 3, N is 4. And of course, the @ symbol is 5. So I'm going to say over here right now, 5. Okay. And then I can say domain equals email. And now inside, we want to start from what? The 6th index, which is going to be L, colon, and then leave that blank because we're going all the way to the end of the string. And now this should work. So all we got to do is to say print. And now in here, let's say username. Okay, and then comma, username. And then print, in brackets, colon, domain. Okay, comma, domain. And there you go. Let's run the program. And there it is. Username is admin. Domain is labcyber.com. Yay. But hold up. Just a minute. Before you pop the champagne, let's run another test. Okay. I'm going to change admin here to, I don't know, let's say Alex, for example. Now if I run the program, we do have a problem. You can see right now that the program has malfunctioned. It's no longer working properly. Instead of username Alex, we have Alex at, and instead of labcyber.com, we have abcyber.com. What is going on here? See, by trying to extract our strings, by being very specific with the index values that we want to target, the program is going to rely very heavily on the actual email address having the right number of characters both before and after the @ symbol. So it's heavily dependent on that, but we don't want that. We want the program to be flexible enough to always be able to accurately extract both the username and the domain, regardless of how short or long the actual email address is. So what can we do? Well, remember that the @ symbol is where all the action is. To the left of the @ symbol is our username. To its right is the domain. So we can target specifically the index value of the @ symbol. And how do we do that? For the username email, right now, again, we're going to leave the first part of the colon blank because we're starting from the very beginning, right? And now, to target the actual @ symbol, its index value, I'm going to say email again, and now dot index, and now in brackets, quotes, the @ symbol. So now I'm saying the username always start from the very beginning of the string and then end once you've reached the index value of the @ symbol. Likewise, we can do something very similar with the domain. We can say domain, okay, let's start from the beginning in here, email.index. And now what are we targeting again? We're targeting the @ symbol. However, we specifically want to target the very first character, the very first index after the @ symbol. So what do you think we're going to do? We, the good people, we're going to say +1. +1. So now we're saying, okay, start from the index value of @ but then add 1 to it. So it's going to go to @ and then add 1. Okay, now L, labcyber.com. So now if I run the program, there you go. It works. Alex, labcyber.com. If I change Alex back to admin and I run the program, you can see it works. In fact, let's try something completely different, okay? Let's say Jack Daniels at superyahoo.com, something weird, right? Let's run the program, and there you go. Jack Daniels, and then the domain superyahoo.com. So this is how to successfully and efficiently extract your strings without making use of the split function. We simply used the index values and we targeted specifically the index value of the @ symbol, because remember again, the @ symbol is where all the action is. To the left of the @ symbol is a username, to its right is the domain. So I hope you enjoyed the video. Thank you for watching. I will see you in the next class. Welcome officially to the third section, and now the fun really begins. Now we're starting to take a sort of a deeper step or a bigger step into the world of Python programming, because here we're going to be talking about control flow and loops. Now, so far in the previous two sections, we've talked about strings and integers, and the programs have been pretty, for the most part, basic, right? You can either maybe have an input, or we provide ourselves with some string and integers, and then we say, okay, I'm going to do this and do this and do that, and then simply print, right? But now with control flow and loops, what if we wanted to say, okay, if something is this, then let us do that. But if something isn't this thing, let us do something else. This is control flow and loops. Also, what if, for example, we had like a list? Okay, it could be a list of names, a list of books, a list of passwords, right? And then we wanted to like go through each password in that list and do something, right? Maybe we wanted to take each password and encrypt them, or maybe we wanted to take each password and then check to see if the password is actually strong or weak, depending on several kinds of conditions. We're going to cover that in this section. This is going to be one of the major sections in this particular course, and I'm really excited to teach you about control flow and loops. Let's begin. We're going to take a break from Replit and talk a little bit about algorithms, because believe it or not, we're actually going to start working with slightly more advanced concepts in Python programming. And it's very, very important for you to understand what algorithms are, because they are vital, not just for Python, but any kind of programming language for that matter. Now, if I was to give you kind of like the standard definition of what an algorithm is, it's basically just like a set of instructions that need to be followed in order to arrive at a particular result, okay? In this case right now, you can see this text. I have written some stuff there. The very first statement says, if the computer is running fast, finish. Now, what do I mean here? I'm simply saying that, look, if our computer is performing very, very well, it's running very, very quickly, there is no need to check for anything. It's fine, right? That's why I said finish. But then notice on the third line, I said else. You could also say something like but, right? But in programming language, we don't use but, we use else, all right? So else basically is signifying that if the previous statement is not correct, so if the computer isn't running fast, okay, then what do we now need to do? We need to first of all check if there is a virus. And then after that, we might need to uninstall unnecessary programs. And then we might eventually need to increase the RAM. So if we follow these three steps, our computer will be guaranteed to run faster. This is an algorithm, right? And two keywords here are the if and else. We're going to be working with this quite a lot in this course. And if you are ever going to work with a different kind of programming language, you will always come across if-else statements. These are fundamental building blocks of any program. I hope you understand what we did here. Pretty straightforward. I'm going to make this just a little bit more advanced, okay? Just a little bit, all right? Let me open up the second tab. So, imagine you're getting dressed based on the weather. Okay, so the very first statement, we've established a scenario, right? So our program is checking to see what we should wear based on the weather. So we have the very first result. If the weather is sunny, okay, well, we can wear our sunglasses. However, notice the third line, it goes else if. It's no longer just else. Why? Well, because the weather can come in various forms. It could be sunny, it could be rainy, it could be snowing, it could be cloudy. There's a lot more options, right? In the very first document here, there are only two conditions. The first condition is, okay, is the computer running fast or is it not running fast? That's it. Nothing like, oh, is the computer running at 25% capacity? Is it running at 50% capacity? We don't have any other conditions. It's just two. Either the computer is running fast or it isn't. It's either A or B. That's why if else would work perfectly here. However, in this example, we have more than two options because, again, we're dealing with the weather. So, if it's sunny, we can wear our sunglasses. Else, if it's raining, okay, we can take an umbrella. And then else, if it's snowing, we can put on a heavy coat, right? But now look at the very last line. It simply says else. Not else if, else. Because basically we are concluding the program here. We're saying, okay, we've checked if it's sunny, we've checked if it's raining, we've checked if it's snowing. So if it's none of these three, is going to be just a normal day. So else, just dress normally. Okay? So the very first one here again is simply if else because there are two conditions. The second one here, we do have the else if statement because there's more than two conditions. In fact, there are four different results based on the weather. That's why we can no longer just work with the if else. We have to introduce the else if statement. So hopefully you understand why we used the if else statement in here and why we used else if in here. If you don't, maybe hopefully once we begin to create actual programs using the algorithms, you will understand it much better then. But this has been an introduction to the world of algorithms as well as the if else, else if statements. Thank you for watching. I will see you in the next class. So in the previous video, we briefly discussed the concepts of algorithms as well as the if else, else if statements. Now we're going to put it into action. We're actually going to write a program that will request a number between 1 to 9 from the user. Now, if the number is greater than 4, we are going to say, why so much? Else, meaning that if it is 4 or less, we're going to say, why so little? Now, the very last line, I have blurred it for a particular reason because once we write this first program, we're going to add an extra condition. I don't want to show you what that extra condition is just yet. So let's focus on writing this program, all right? So let me just drag this away, all right? And let me just remove this. Okay, so the first part of the program is we want to request a number between 1 to 9. So what can we do here? Well, first of all, we can create a variable called n, all right, for the number. And we're going to pass, remember we worked with the input function. Okay, so I'm going to say input because that's the function that will request an input from the user. So I'm going to say input and I'm going to say enter a number between 1 to 9. Okay. Let's just first of all make sure that this is working. Okay, enter a number between 1 to 9. Let me just create some space between the 1 and 9. Run again. Okay. All right. So the first line works. Now we want to check if the number is between or is less than 4, right? So I'm going to say if, all right, and then the integer, because we want to convert whatever number we're provided, we want to convert it to an integer because the user could be very naughty. They could decide to provide, say, 1.1, 4.5, 7.6, something like that. So we want to keep everything as an integer. So I'm going to wrap our variable right now in the integer function. All right. So I'm going to say if integer n, okay, and now space, and then the symbol for greater than 4, okay, and now pay very close attention. I'm going to add the double colon, okay. You need to add this whenever you're working with your if-else statements, okay. So I'm going to save that, and now by default, actually Python has written out this line for me, but I'm going to say why so much, okay. Now enter, and now I'm going to say else if, however, okay, and now I'm going to say else, and then new line, indent, print, and then I'm going to say why so little, okay. So I'm gonna go ahead right now. Oh, by the way, make sure in your else you also have the double colon as well, okay. Let's go ahead right now and run the program, and let's see. So enter a number between 1 to 9. I'm going to say 6. Press enter. You can see right there, it actually works. Why so much? Let's run the program again. I'm going to say 3. 3 right there. And then it says why so little. So it actually works, as you can see. Now I'm going to go over this once again, okay? So first of all, we have n, which is going to be the variable that will accept the input from the user, and the input is requesting enter a number between 1 to 9, okay? So now we're going to create a condition that will check to see the value of that number. So we have decided to convert the input to an integer. That's why we have the int. A question you might have here is, wait a minute, Alex, previously when we had a function inside of another function, we had to use the brackets, right? The if else, it's not exactly a function, okay? It's more of an algorithm, more of kind of like a loop, just checking to see the value of something. It's not an actual function itself. That's why we don't have the integer wrapped in brackets, okay? So it's gonna check if the integer n, if it's greater than 4, well, print why so much, else, meaning that if the number is 4 or less than 4, print why so little. You can see it works, right? And the only thing you need to pay attention to would be the double colon after the 4 and also after the else. And then it's also very good practice that whenever you're working with if-else statements or else-if, you have good indentation. I didn't do this, okay? I didn't have my print statements directly underneath the if and else statements. This is not good at all. This is very, very poor programming syntax. So you always want to have your indentation correctly, okay? Have that whenever you're working with the if-else statements. Okay, now I'm going to bring back our program, and look at that. I've added an extra condition saying that what if the number is a specific number, which is 5? Well, we want to say bingo, okay? So how exactly are we going to do this? Okay, let me drag this away. Okay, now check this out. I'm going to come over here where it says print why so much, and I'm going to press enter because we want to add the else if in between the opening if statement and the closing else statement. Okay, so now I'm going to say if. Else, this is the short form of writing else if. So instead of saying else if, we use elif in Python, okay? So elif, the integer n is equal, the integer n, if it's equal to 5. the equal is going to be double equal signs, not just one, okay? So else if the integer provided by the user is 5, and now I'm going to add the double colon, and then I'm going to say, I'm going to say print, and then in brackets, bingo. Okay, so I'm going to go ahead right now, run the program, and now let's check to see if this actually works. First of all, I'm going to type in 3, okay? Okay, so it's still working. Why so little? Okay. Let's try 8. Why so much? Okay. And now, if I say 5 and I press enter, guess what? It's not saying bingo. It's still saying why so much. You want to know why? Because the Python program executes line by line. Now look at the hierarchy in here. The very first condition that Python is checking for is to see if the number is greater than 4. And because 5 is greater than 4, it immediately says, okay, why so much? It doesn't even go further down to check if the number is equal to 5. Because the very first statement is basically saying, hey, if the number is greater than 4, then print why so much. So to prove this to you, what I'm going to do here is this, okay? I'm going to say that let's actually change the hierarchy in here. So we will check, first of all, if the integer is actually equal to 5. Okay, let that be the very first thing it checks. And now over here, we will check to see if the integer is greater than 4. So I've basically just changed the hierarchy. So the very first thing it's going to check right now is if the integer is actually equal to 5. It's going to say bingo. Else if it's not equal to 5, and it's greater than 4, we're going to say why so much. And then else, if it's not equal to 5, and if it's not greater than 4, then print why so little. Okay? Let's run the program. So I'm going to come over here right now, run. Let me first of all add 5 now and see. Enter. And there you go. Bingo! It actually worked. Let's run the program again. What if I typed in 2? Enter. Why so little? Run once again. Let's go with 7. Enter. Why so much? So you can see right now, it works. So the hierarchy of your commands is extremely important whenever you're working with Python or programming in general. When you're checking for conditions, always keep in mind that once Python has gotten a condition that's satisfied, it will immediately print out the result. It's not going to go any further down the remaining lines in your program. So the hierarchy of your conditions, the conditions that are checked, your commands is so important. And then of course also this little, knowing where to add the colons, things like that. This is something you will eventually get used to. It might be a bit overwhelming in the very beginning, but as you begin to write more programs, you will eventually grow accustomed to them. So that's it for working with the if, else, if statements. Thank you for watching. I will see you in the next class. All right, so let's write our very first piece of code related to cybersecurity, and this one will check to see if a user-entered password is actually valid or not. You're more than welcome to try writing the code on your own. If not, let me show you how you will do this. So the first thing we need to do is we need to indicate what the password is. So I'm going to call the variable in here stored_password. Okay, and let's provide a value for the password. I'm going to go with something very generic. Let's say password 123.
Okay, so this is going to be the actual password. By the way, I'm not sure if I've mentioned this before, but in Python, if you wanted to add like a comment or a hint in your code, you can do so by using the hashtag symbol and then type in your comment. Okay, so maybe I've mentioned this before. If not, well, there you go. Okay, so start password here is going to be password 123. So now we need to ask the user to provide the password, and then once they provide the password, we can then run an if-else statement that will check to see if the password they've typed in is actually correct or not. If it's correct, we can say access granted. If not, we'll say access denied. So the first thing I'm going to do right now is I'm going to get the user input. So let me just add my comment and say get user input. That's the first step. So what we'll do right now is we can call the user input, we can call it the entered password. Okay, this will be the variable that will store the input. So right there, I like the suggestion that Python has given us. So it simply says entered password equals input, and then we're going to ask the user to provide their password. So the next thing we need to do right now is to see if whether or not the passwords actually match. Okay, we want to make sure that whatever they type in here is going to match the password that we have stored. And by the way, it's kind of amazing how, I don't know if you're seeing the exact same thing on your own screen, but Python is literally just writing the entire code for me. And I promise you, this is the very first time I'm actually writing this code on Replit. I promise you, I haven't written this code before. It's amazing how it's so smart, it's so intelligent, it knows exactly what I want to type, and that's exactly what I want to do. I want to say, okay, if the entered password is equal to the stored password, what are we going to do? We are going to print, okay, and then in brackets, string access granted, right? Else, sorry about that, else, what are we going to print? We're going to print brackets, quotes, access denied. And there it is. Let me remove the extra quote right there. And there you go. That is our code right there. Very simple, very straightforward. Let us try it. So I'm going to run, and now I'm going to ask for the password. Let's try James123. Did that work? Nope. Access denied. Well, it did not work. Let's run the program one more time. Let's now try password. Password 123. Press enter, and there you go. Yay, access has been granted. So our code actually works properly. And of course, this is just a very simple block of code. It's not the entire program itself, but this is the very first step towards creating a more comprehensive password checker tool. Thank you for watching the video. I will see you in the next class.
Let's now talk about loops, which are easily one of the most important aspects of any kind of program or programming language. But what exactly are they? Well, they are used typically to repeat a block of code multiple times until a specified condition is met or for a set number of iterations. In other words, a loop will run until all items in a sequence or list have been processed, or the loop will continue to run while a condition continues to be true or is satisfied. So basically, it's a loop. It will keep going on and on and on and on until something eventually happens. Now, they are very important because they help us to automate repetitive tasks. So instead of us having to repeat the same task over and over again, we can just write a loop that will run that task for us automatically. And of course, we use loops for building efficient programs that will adapt based on dynamic conditions. Now, when it comes to loops, there are two main types. The first one is going to be the for loop. Look at this, okay? We have a list of 1 to 9, okay, numbers. And we can write a very simple program that will say, hey, print each number out. So basically print 1, 2, 3, 4, 5, 6, 7, 8, 9. But instead of us having to write each individual line for each individual number, say, print 1, second line, print 2, third line, print 3, we can just write a loop that will go through all the numbers in this list and then print out those numbers until, of course, the last number has been printed, which is 9. This will be the definition of, or an example rather, of a for loop. The second one is the while loop. So say, for example, the time is between 12:01 p.m. and 4:59 p.m. So as long as the time of the day is between this range, say good afternoon. Notice the difference between the two structures. Okay, the first one here, which is the for loop, already has like a predefined list or a sequence. And as long as we have items in that particular list, then do something. The while loop is a little bit different because it says, okay, as long as this condition continues to be satisfied or this condition continues to be true, what is the condition here? As long as the time is between 12:01 p.m. and 4:59 p.m., say good afternoon. All right. In closing, loops must have an endpoint or will run forever. Basically, a loop can crash the entire program. Let's look at the example in here. What if the numbers in this list was number 1 to infinity, right? That means the program will continue to print the numbers over and over and over again, and it will never stop. This will easily crash the program. And what if in this example right now, there is no specified time period? What if the program just checks to see if it's during the day or anytime during the night? Just say good afternoon. Well, it's always going to simply print out good afternoon, good afternoon, good afternoon, good afternoon, and it will eventually crash the program as well. So it is very, very important that whenever we're working with loops, there must always be a certain kind of condition that will eventually be satisfied for that loop to end. Otherwise, it will crash the program. Thank you for watching the video. I will see you in the next class. Let's now go back to our trusty Replit, and I'm going to give you two examples, one for the for loop and another for the while loop. So in order to create our for loop, let's first of all create the list. In this case right now, I'm going to provide the name of the list as names, okay, equals, and then I'm going to have my brackets in here, and let's add some names. So I've got Alex, I've got Nancy, and I've got James, and let's say last but not least, I have got Violetta. Honestly, I just came up with that name. Violetta. Okay, so we have our list right here of 4 different names, right? Alex, Nancy, James, and then Violetta. One thing I can now do right now is we can create a variable that would represent each item in the list. Kind of like how we've been assigning values to variables like, x equals 4, y equals 7. I can now come in here and then simply say for, okay, and now I will say for x in names. Okay, what this does right here, and let me just add the colon right there. So what we've done with this statement here is that we're saying, okay, we are going to use x to represent each name in this list. So X will be equal to Alex. That will be the first loop that will run. The second loop, X will now be equal to Nancy. It will run. The third loop will now be X equals to James. And then finally, the very last loop will be X is equal to Violetta. That's basically what this does in here. So we're saying for X in names, and now we have to tell the program, okay, what should we do? Well, we should print out the name X. Okay, I am going to run, and there you go. Alex, Nancy, James, and Violetta. But what if I wanted to spice this program up just a little bit, and let's say something like, good morning, and then the name of that person. So we'll have good morning, Alex, good morning, Nancy, good morning, James, and of course, good morning, Violetta. How are we going to do this? Well, inside of the print function, I am going to add our string that will first of all say, good morning. Okay. And then we're going to have the comma, which, by the way, is just part of the actual print out itself. It's not part of the actual program, if you know what I mean. It's part of the string, basically, is what I'm trying to say. We can do so without the comma as well. In fact, you know what? Let me remove the comma just so I don't confuse you. So I'm going to say good morning, okay? And then I am going to add a space because we want there to be space between the actual string good morning and then the name of the person. That's why I've added the space right there, okay? And then right here, I am going to add the plus sign and then X. So we're basically attaching the string good morning to the name of the person. Let's run the program, and there you go. Good morning, Alex. Good morning, Nancy. Good morning, James. Good morning, Violetta. Now, if I remove this space, because I want you to understand this very well, if I remove this space right now and I run the program again, you can see right now that it's all jumbled up, okay? There's no space between morning and then the name of the person. That's why, once again, I added the space right here between the G and the closing quotation marks, okay? So, one more time, and there you go. This is an example of a very simple for loop. First of all, we created our list of names. We assigned this entire list right here to the variable names. And then we now need to create another variable that will represent each item, each name in this list. So we said for X in the list called names. And now the function print good morning plus the name of the person in that list. This is an example of your for loop. Now, what I'm going to do is we're going to create a while loop. Now, to do this, let's come down here. And yes, we can run multiple programs and functions within the exact same file. All right. So what I'm going to do right now is I'm going to create something called a counter. Okay, so counter equals 0. Now, what exactly am I doing here? What is this counter? Remember that with while loops, they will continue to run as long as a condition continues to be satisfied. That's the difference between a for loop and a while loop. With the for loop, we have our list of items, right? So the loop will simply run through all the items in that list. But a while loop, there has to be some sort of a condition that will be presented. And then we're going to tell Python that, hey, as long as this particular condition continues to be satisfied, execute the loop. So the condition here right now is that while our counter is less than, let's say, 3, do you now see? We're saying, hey, as long as our counter, as long as the number in here is less than 3, continue to do something. And you can see Python kind of already giving us a hint of where to go next. Well, I'm going to say print, print, and then I'm going to add the text right there, the string, hello. Okay. And there you go. Now, what we're saying here is start from 0. Okay. start from 0 and then check to see if 0 is less than 3. If it's less than 3, then print hello. However, we're not actually done. Why? Well, because we haven't specifically told Python to add a new number to the counter. So instead of 0, it will now become 1. Check to see if 1 is less than 3 and then print out hello. We haven't told Python that yet because a loop can go either way. We can either continue to add 1, 2, 3 to 0, or we could go the opposite direction, and then instead of 0 going to 1, it could be 0 going to -1, -2, -3, -4. And in that kind of scenario, those numbers will always be less than 3, and the condition will never be satisfied, or rather, it will always be satisfied, rather, and then that will crash the program. So we need to tell Python explicitly that, hey, once you've run the very first loop where 0 is less than 3, add 1 to the counter. So I'm going to come in right now and I'm going to say counter and then plus equals 1. This is our way of saying, okay, Python, the very beginning of the loop will be 0. Check to see if 0 is less than 3. If it's less than 3, print hello. And then now add 1 to the counter. So it will now be 1 less than 3. Python says, yes, 1 is indeed less than 3. It's going to print out hello. It's going to add 1 again. So 1 will now become 2. Python is going to check, okay, is 2 less than 3? Yes, it's less than 3. Print hello. And then it's going to add 1 again. So 2 now becomes 3. And then finally, Python will say that, okay, 3 isn't less than 3 because 3 equals 3. And then it will end the loop. Okay, let's go ahead right now and run. And there you go. Hello, hello, hello. You can see right there that it stopped at 3 loops because the very first loop will be for 0, second loop will be for 1, third loop will be for 2. If I came here and I said, okay, less than 7, run, now you can see we have, again, for 0, 1, 2, 3, 4, 5, 6 hellos. So that's the difference between the for loop and the while loop. You can see right now with the for loop, we have our list or our array, and then the loop will go through each particular item in that array and it will do something. But for the while loop, we need to first of all specify, okay, what's the beginning point? And then we'll now provide the condition, okay, as long as this equals this, or this is less than this, or this is this, do something, and then either like add 1 or remove 1 or just do something to make sure that the loop will now actually begin to run. That's the difference between the for loop and the while loop. Of course, we're going to be working a lot more with for and while loops in this course, but thank you for watching. I will see you in the next class.
Let's now talk about the break statement because it's a very, very powerful statement and we're going to be working with it in this course. But before I do that, I just want to show you a different way of actually printing out the names in this particular example. Right now, we're saying good morning and then plus and then x. X, of course, being the variable representing each name in our list. Another way of rewriting this would be to do something like this. First of all, I'm going to remove the plus x. Okay. But now I'm going to come right here at the very beginning. I'm going to type in F. Okay. And now right here, I'm going to add my curly braces, not the usual braces, but the curly ones. And now here, I'll simply type in X. Okay. I can run the program and you can see right now we have the exact same results. This right here is a different and also a more efficient way of actually printing out the values of the variables in a list or an array in a for or while loop. All right. And we're going to be working like this moving forwards. Now, the break statement. What exactly is the break statement? It's used when we want to terminate a loop early. For example, in this for loop that we're seeing right now, what it does is that it's simply going to go through all the names in our list and then print out good morning and then the name of the person, right? But what if for one reason or the other, we wanted to terminate the loop as soon as James has been reached? We don't want to print out good morning Violetta because we don't like Violetta, right? This is where we could use the break statement to terminate the loop early. And to demonstrate this, I'm going to write a completely different program. Okay, so let's do this, all right? I'm going to type in, let's say, numbers. Okay, I'm going to create a new list right here, numbers equals, and I'm going to put in my brackets in here. And let's go with a series of numbers. I'm going to go with 1, 3, let's go with 7, 8, 10, and let's go with 11, and let's add one more, even number 14. Okay, so we have a list of numbers in here, and what we want to do right now is we want to create a loop that will run through all the numbers. However, once the first even number has been reached, we want to terminate the loop, meaning that once the number reaches 8, we're going to end the loop, so it should run 4 times. The first loop for 1, the second loop for 3, third loop for 7, fourth loop for 8. So think about this, right? We're going to create the for loop first, and then we're going to introduce the if-else statement. So the if statement will check, okay, is this number actually even or is it odd? If it's even, then break the loop because we found the first even number. Else, if it's not an even number, if it's an odd number, continue with the loop. So how are we going to do this? Gonna type in enter. The for loop for, let's say num. Okay, num would represent the numbers. And by the way, I'm not sure if I've mentioned this before, but I think it's time I do so. See, I've only typed in for number. You can see right now on my screen, Python is already suggesting in numbers because Python is actually quite smart, right? So in this kind of situation right now, if you're happy with the suggestion that the program has given you, you can simply press the tab key on your keyboard and you will get the exact same result, right? So I've typed, do forgive me, I can't talk. I've tapped the tab number or the tab key on my keyboard, and now I have for num in numbers. I'm going to add my colon. Okay, now I'm going to add the if statement, and would you look at that? I promise you, I've actually not typed this program before, but I think Python is so intelligent, it already has an idea of what I might be looking for. Yes, I want if num and then %2 equals 0. So what exactly is this? What is going on here? What this means is that we're going to check if the number that's been pulled out, if it's divisible by 2 and the remainder is equal to 0, then we know for sure that it is an even number. If you divided 7 by 2, you will get 3.5, 3.5. There's always going to be that remainder, the remainder being half. But when you divide 8 by 2, the answer is straight up 4. It's not 4.1, it's not 4.2, it's not 4.5, it is 4. So this is how we can check if the number is actually even. So if the number is in fact even, what do? Let's say print, okay. And now I'm going to add the F string, okay. And now the actual string itself found the first even number, okay. Let's add my comma. And now I want to display the actual number, curly braces. And what is it going to be? It is going to be num. Okay, awesome. So we've added what the program should do if the number is in fact an even number. Print says, okay, we found the first number and now break the loop. We don't need the loop to run anymore. Break it. It's over. We found the first even number. We're getting out of here. Else, make sure your tabs, remember the tabulation is extremely important, okay? If and else must be on the same tab, right? They're the same indentation, right? So else, simply print out, let's just say print, let me add my brackets and then my quotes, still looking for that even number. And there it is. Okay, let's go ahead right now, run the program, and there it is. Still looking for that even number, still looking for that even number, still looking for that even number. Oh, look, we found the first even number, and the number is 8. This is the use of the break statement. Now, let's use it in a while loop. Now, to do this, I'm going to come all the way down here, and let's create a very simple program that will ask the user to type in something, and as long as, or type in a particular letter, and as long as the letter isn't equal to Q, then just keep asking the user for a new letter. Okay, so that's basically the condition that needs to be satisfied. So while the user is typing in A, B, C, D, E, F, as long as it's not Q, keep asking the user to input a new letter. So I'm going to say while true. What this does right now, this is a very simple function or loop in Python that automatically has created a condition that is always true unless something else happens. Remember that with the while loops, there needs to be a particular condition that must be continually satisfied in order for the loop to actually run, and then it must be terminated once a very specific condition has been met. So we're going to assume right now that the condition is always true. And now I'm going to type in user input. This is going to be the variable that will represent the letter that the user will actually type in. So I'm going to say user input equals, and now input, remember the function input, which will now ask the user to type in something. So I'm going to say enter a letter. And then in brackets, I'm going to say or type Q. Okay. Type Q to exit the program. Okay. So we're giving the users here a choice. Okay. You can either just type in a letter, or if you want to exit the program, just type in Q. Okay. So I'm going to press enter. So now let's type in the condition that we need to check whether or not the input was actually Q. So I'm going to come in right now, add the if statement. So we're going to check if the user input is equal to Q. What should we do? Well, I'm going to say print in brackets, and I'm going to say you have chosen to exit the program. Just to exit the program, press enter, and there it is. And now, since they've chosen to, let me add the closing quotes here. Since they've chosen to exit the program, we are now going to break the loop. Otherwise, I'm going to come in here right now and then say print, and now F in quotes, you typed, and now remember in the curly brackets, I'm going to say user underscore input, and there it is. All right, going to go ahead right now, run the program. Okay, so now it's saying enter a letter. I'm going to say Y, press enter. Okay, now it says, okay, you typed Y, enter another letter. I'm going to say A. Once again, it's running until I now type in Q, and now it has terminated the program. And this right here is us combining the while statement, the while loop rather, with the break statement. So let me run through this over again. I know you might have a question why didn't we type in the else? Because we have the if statement. Okay, so where is the else? Well, we could actually add the else. It's going to be right here. And I'll just say else. And then the tab right here, print, you typed this. So I can go ahead right now, run the exact same program again. Okay, come in here right now, type in G, it works well. Type in U, it works well. Type in Q, enter, and now it works the exact same way. So the one thing you need to understand here is that the reason why the else statement is actually optional here is because we're working with the while true loop, right? The condition. So it's going to automatically assume that the condition will always be true. And now we're using the break statement here to intentionally control when the loop would actually end. So there's really no need for the else statement here. The loop will always run because we have said while true and will only stop via the break statement once the user has typed in the letter Q. So really the else statement here is not necessary. You can still type it in. The program will still work perfectly fine. But whenever you're working with the while true and then the break statements, you don't need to add the else condition anymore. So we've done quite a lot in this particular video. Hopefully, you've been able to follow, and hopefully you now understand how the break statement is used. Thank you so much for watching the video. I will see you in the next class. Welcome back. So in the previous lesson, we successfully created this particular program that would accept input, positive numbers from the user. It will store the numbers in a list, and it will continue to do so until the user types in the word done. And at the end of it, it will print out, if there was an even number, it will print out what the first even number was, and will also eventually print out all the numbers in the list. However, one thing we discovered was that when we ran the program and we added, let's say, for example, instead of an actual integer like 8 or 9, we added, let's say, 8.6, right? When we press enter, we ended up having this particular error message, a value error. Now, if we run the program again, and instead of 8.5, I said, IOF, I typed in letters instead, I press enter, you can see once again that we also have the exact same error. And that's because our program has been created in such a way that it is expected to receive positive numbers only. If we run the program one more time, and I typed in, let's say, -6, which is a negative number, and I pressed enter, you can see that it actually kind of works in a way. It does accept the -6 because it is an actual number. It just happens to be negative. But that still defeats the purpose because we only want the user to type in positive numbers. So it shouldn't even have accepted this -6. So we do have quite some issues with our particular program, and we need to now introduce something known as the try and then the except block. So the try block in Python is basically part of what we call an exception handling mechanism, which would basically allow us to catch and handle errors that might occur during the execution of our code. So if an error occurs inside of the try block, the program will not crash. Instead, the error will be caught, and the code inside the associated except block will then be executed. Keep in mind that it's not just about users making a mistake whenever they type in their inputs. It's also possible that a hacker will deliberately try to insert values that the program will not accept in an effort to actually crash the program. This is why we need to always make sure that our programs, whenever they're accepting inputs from the user, we create and design them in such a way that they're able to handle our wrong inputs from the user. So how are we going to now catch any particular errors? Well, I'm going to come over here where we're breaking, okay? So the reason why we're starting here is because this is where we're going to check whether or not the user has added either the done word or an actual number. So after break, right? After break, because break will check, okay, is it done? If it's not done, then it's now going to execute. This is where we're now going to type in the words, or rather the word try, because this is where we want the program to catch an error if there is. So now it's going to be try and then colon. And now this right here, we can simply tab that. Okay, I'm just press enter right here. So we are saying right here that if the user types in done, simply break the program. Break the loop. However, if it's an actual number, let us check to see if that number is positive. So right now we have created the variable num. We've added the user input to num. So now let us check to see if it is positive. The easiest way to check would be to simply say if the number is less than 0. This is the easiest way to check. So if the number is in fact less than 0, we're going to say print, please enter a positive number. Okay, and now else, because after if comes else. So now else, if it was in fact a positive number, we are now simply going to append. Okay, we're going to append the num variable to numbers, and that's it right here. Okay, and finally, because we have try, we're going to close it out by using the except statement. So basically, what we're doing right here, we're saying, hey, if the value provided by the user was in fact less than 0, then print, please enter a positive number. But then what if the user didn't type a number? What if they typed in letters or strings, basically, right? So this is where the except will now come in. So we're going to say except value error. Okay. So if there's an actual error within the value itself because it's not a number, we're now going to say print, please enter a valid number. And that's it right there. So let us try and see if this will work. So I'm going to go ahead right now, run the program. Okay. So what I'm going to do right now is I'm going to end -6, press enter. You can see right here it says, please enter a positive number. But what if I typed in a string like this, for example? Now it says, please enter a valid number. You see how this works, right? So let me walk you through it all over again. Basically, right here, where we're accepting the input from the user, we want to check to make sure that it's actually a positive number. The best way is if that number is less than 0, then we know it's negative. We can print out, please enter a positive number. If on the other hand, it is greater than 0, we know it's a positive number. We can go ahead right now and append the num to the numbers list. And now we will have to say, okay, but what if there was an actual error within the type of input that the user inserted? Maybe it wasn't a positive number, or so maybe it wasn't even a negative number. Maybe it was like letters or words or something else entirely. We can then say, please enter a valid number. That's where the except comes into play. So that's it for the try and except statements. Thank you for watching the video. I will see you in the next class. Before we round up the section on loops and flow control, I want us to take a look at one more statement, and that's going to be the continue statement. So far, we've been working with the break statement, and this is, of course, used to end the loop once a particular condition has been met. But what if, for one reason or the other, we simply wanted to skip a particular iteration or a part of a loop? We don't want to end the loop exactly. We just want to skip a particular step. This is where continue comes into play. So let me give you an example. Let me just remove this code. And let's say for number in, and now range 1, 6. Okay, now you're probably wondering what exactly is range. Range here is simply an inbuilt function within Python that will generate numbers between a certain range. So in this case right now, we're saying numbers between 1 and 6. However, please do keep in mind that when you're working with the range function, the first number here, which is 1, will be inclusive, while the last number here, which is 6, will not be inclusive. It will be exclusive. So if I was to simply say, okay, just simply print, and then in brackets, just print the number, you will see right now that we're going to get 1, 2, 3, 4, 5. Okay, so please do keep this in mind. Now, the function by default will print 1, 2, 3, 4, 5, right? But what if we wanted to skip 3 in this case? Okay, so we want the program to print 1, 2, 4, and then 5, right? So how are we going to do this? This is where the continue statement is going to come into play. But first of all, I need to create the if statement to check if the number is equal to 3, right? So now I'm saying, okay, if it's equal to 3, just continue. I don't need to add the else statement in here because when you're working with the continue statement, it is understood. So Python will simply say, okay, once I get to 3, I'm going to skip it out. I'm going to skip 3 and then simply continue with the rest of the loop. So now if I was to run the program, now you can see it is 1, 2, 4, and then 5. So that's basically how the continue statement would work. Let me give you another very quick example. What if I extended the range here from 1 to, let's say, 11, okay? But now we wanted to check for numbers that are even and then simply skip those even numbers. We only want to print out the odd numbers. So again, how are we going to do this? Let's first of all check to see if it's divisible by 2. So I'm going to say percentage and then 2 right here equals to what? Equals to 0. Add my colon. And now I'm simply going to say just continue and then print number. So now if I was to run the program, now you can see it's simply 1, 3, 5, 7, and 9. That's how the continue statement actually works. Let me just spend 1 minute to talk a little bit further about the range function. There is one more thing that you should be aware of. The thing about the range function is that it can actually accept 3 values. So as an example, let me just add my hashtag. So for example, with range, you can have something like 1, okay, 10, and then 2, okay? So the range function can accept 3 different parameters, all right? So if you're wondering, okay, what exactly are these going to be? Well, the very first number in here will represent the start value, which is 1. The second here will represent the stop value, which is going to be 10, while the third value right here will represent 2, which will be the steps that must be skipped. So by default, let me just show you how this will work right now. If I was to come over here right now and then say 1, 10, 2, just as an example, let me just remove the continue statement in here. Okay. If I was to go ahead right now and print these numbers, you will see that it is now 1, 3, 5, 7, and 9. Why? Because we're skipping every 2. The step is going to be 2. So it's going to go from 1, it's going to skip to 3, it's going to skip to 5, and so on. If I was to change this one right now to 3, can you guess what the values are going to be? Now it's going to be 1, 4, 7. So if I run the program, there you go, 1, 4, 7. So you may or may not work with the range function in the future, but I just felt it's important for you to at least understand that the range function can accept up to 3 different parameters. The first value in here being the start, second being the stop number, and then the last value in here being the step number. And keep in mind that the stop value is always exclusive. It's not going to be included in the actual results of that particular range function. Final thing to mention, you may also come across a particular statement called the pass statement. It just goes like this, right? Instead of continue, for example, you will see pass, right? Pass doesn't really do anything, honestly. It's really used for passing comments. Maybe the developer of the program doesn't want to execute something yet, but wants to leave like a note. That's what the pass statement is mostly used for. We're not going to be working with it at all. So for example, in here, I could say something like, okay, pass, and then I can add my hashtag, and I can say I will add the function later. Okay, just as an example, right? So let me just go ahead and run the program, and you can see right now the program still works anyway, right? So it doesn't really do anything as such. So that's pretty much it. Thank you for watching the video. I will see you in the next class. Okie dokie, it is now time for us to try to put together everything that we've learned so far to write a program. And the program we want is the one that will prompt the user to keep entering a positive number, or else if they want to exit the program, they can simply type in the words or the word done to exit the program. Okay, so basically we're saying, hey, user, keep adding a positive number, keep on adding the number, keep on adding number. Whenever you're ready to exit the program, just type in done, right? Now, as the user is typing in the numbers 2, 3, 4, 9, 11, whatever it is, we want to add those numbers to a list. We want to be able to keep track of all the numbers that the user keeps on providing us. So we're going to add those numbers to a list. But we also want the program to check the even numbers that the user has added and keep track of the very first even number that was provided, so that we can print out and tell the user that, hey, this was the first even number that you added, and then we can indicate what that number was. Otherwise, if the user added only odd numbers, then we can just simply say, okay, no even numbers were found in your list. Now, once the user has added several numbers and then finally decides to exit the program, we want the program to print out all the numbers that were added by the user. And if the user never even added a single number, just say no numbers were entered. Okay, so let us tackle this step by step. First of all, we're going to want a list, right? Let's call that list numbers, okay? So we're going to be adding all the numbers entered by the user. We're going to add them to this list called numbers. So obviously, we're going to make use of the input function to, prompt user to add numbers, right? Okay. And we're going to have to create a while loop in this scenario because we want the user to keep on adding a number or providing a number until they choose to exit the program. So we can say, while true, and then the user keeps on adding a number. And then we want to check if the number that was provided by the user was actually an even number. Okay, so we're going to have some sort of like an if-else statement that will check if the number, if it's divisible by 2, if that equals 0, then print a even number, stuff like this. Otherwise, just say no even numbers were found. But what else? Remember that we also want to keep on adding the numbers that the user has provided. We want to add them to the list called numbers. So we are going to have to append the user input to numbers list, right? And we're going to make use of a new function here called append. All right, don't worry, I'll show you how that works. What else do we need to keep track of? That's pretty much it at this point, right? So first of all, we create our list called numbers, and then we're going to have to prompt the user to add the numbers, check to see if the numbers are even. Once the very first even number has been found, let the program keep track of that, and then at the end, print out what that even number was. And then, of course, also at the end of the program, once the user has decided to exit it, simply print out all the numbers that the user added. So let us do this, all right? I'm going to move this away and let us begin. So first things first, let us create our empty list that will contain all the numbers provided by the user. So numbers equals and then empty, okay? So That's the first step we're going to do. Now, let us prompt the user to add the number. So I'm going to say while, and now true, colon. Now we want to prompt the user to provide some numbers. However, we'll have to assign users input to a variable. So let's say user underscore input. Okay, this will represent whatever the user adds. So user input in here equals to input brackets. And now let us prompt the user to enter a positive number. Okay, or in brackets, I could also just type done to finish. Okay. So far, so good. We've assigned numbers. We have our empty list right there. This will collect the numbers provided by the user. And now we've created our loop to prompt the user to keep on adding a positive number or type done if they decide to finish. So what we're going to do right now is let us check to see if the user has actually typed the letters done or typed done. Okay, because we don't want the program to keep on running if the user decides to type done. So I am going to say if user underscore input is equal to done. If the user actually types done, what are we going to do? You guessed it, we are going to break the loop. All right, let me add some space in here. Okay. All right, so we've checked to see if the user has typed in done. If they did, break the loop. However, if they typed an actual positive number, what do we want the program to do? We want the program to add that number to the numbers list. Okay? So how are we going to do this? We need something to represent the numbers that will be provided by the user. In this case right now, don't get it twisted. The user input, the variable in here, is simply representing the input in here. Enter a positive number or type done to finish. That's what it's representing in here. The actual numbers themselves, we'll have to create a new variable for that. So for the variable in here, I am going to say num. Okay, num is going to be equal to int. Remember the integer function that will convert whatever the user types in. So it's not going to be integer and now underscore input. Okay, so basically whatever the user types at this line right here, where we say enter a positive number, if the user types in 5.2, for example, okay, convert 5.2 to an integer which will now be 5, and then assign 5 to the variable called number, num. Now the next step will be to add this number that the user has added to the numbers list. And how do we do that? I'm going to type in numbers, and now check this out, dot append, and now in brackets num. So this right here, this append is going to be the function that will now begin to add the numbers added by the user to the numbers list. Let's go over it one more time. So first of all, we have our empty list called numbers. Let's create the loop called while that will prompt the user to keep on adding a positive number. However, if they typed done, if the user input is equal to done, break the loop, no need to continue. But if the user actually added real numbers, assign those numbers to a variable called num, num, and now start to append those numbers to the numbers list. So far, so good. What else do we want to do? We want to check to see if any even number is being added. So what are we going to do? We are going to create a for loop. Okay? That loop is going to go through all the numbers in the numbers list and then find the very first even number. So check this out. I'm going to say for num in what? In numbers. That's right. Now let's add a colon. Let's create our if else statement. So if num divided by 2 equals to 0, what do we want the program to say? We want the program to say print, and now our brackets. Let's add our f string, and then we can say found the first even number, and then of course curly braces, and then num. Okay? Otherwise, if the number that was added by the user isn't even, simply break. Let's just break it, okay? And now we can add our else statement to do something, and we can say else colon, and now we're going to say print, and we're saying no even numbers were entered by the user. And there it is. However, again, the indentation is very, very important. Keep in mind that this else is under the for. Okay, so it's not if else, rather it's the for else statement in here. So just make sure that you don't make the mistake. The indentations are going to be very, 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 very important. So it's basically for, and then num in numbers. If num divided by 2 equals 0, print, we found the very first number, and then print out what the number is. Otherwise, simply break the loop once that number has been found. Once the very first positive number has been found, the first even number has been found, and then if no even number was added by the user at all, they just simply print out no even numbers were entered by the user. Okay, last but not least, we'll now have to print out all the numbers the user has added at the end of the program. So I'm going to come out here right now, add the new if statement, and simply say if number. So if the user actually added some numbers, so if numbers, guess what? Simply print, and now I'm going to say f, and now in quotes, the numbers you entered are, and then curly braces, now numbers. Otherwise, so that's going to be else, simply print, that is if the user did not add any numbers, we can just say no numbers were entered by the user. Woo, let us try. I'm going to go ahead right now, run the program, and so we do have a bit of an issue right here. It says line 23. Okay, print f. What did I do wrong in here? Oh, there shouldn't be any space. Sorry. There shouldn't be any space right there. You see how just a single space can ruin everything? It's kind of infuriating, but yeah. So whenever you're using the f strings, make sure there is no space between the f and your quotes. So let's try that again. Run. Okay, so I'm going to add 1. All right, let's add 3. Let's add 4. Okay, let's add 5. Let's add 8. Let's add 6. And now I'm going to type in done, enter, and there you go. The first even number was 4, and now we've typed in the other numbers, which are 1, 3, 4, 5, 8, and 6. So you can see right now, the program actually works. So let me run through the program one more time. First of all, we created our list called numbers. This will hold every single positive number added by the user. Next, we created the while loop that will continually prompt the user to keep on adding a positive number, or if they choose not to, they can simply type in the word done to finish the program. So we now needed to check if the user actually typed in done. And by the way, let me even try that, okay? Let's run and let's just type in done instantly and see. Well, there you go. So the program works very, very well. So it actually checked to see, hey, did this user type in done? Oh, it did. Okay, so if it typed in done, then simply break the loop. We don't need to run the loop any longer because the user has typed in done. So in that case right now, in this scenario where the user has typed in done, basically all of this stuff right here is completely irrelevant, okay? The Python program will go straight from the break statement all the way down here to simply saying, hey, first of all the way right here, it will first of all say, hey, no even numbers were entered by the user, and then finally, no numbers were added by the user. So all this num equals integer, if num, it's going to skip all of that. But what if the user actually typed in a number? What do we want the program to do? Well, we want to add that number to our numbers list. So we need to assign the user input to a variable. In this case right now, we created a variable called num that will represent the input provided by the user. And we also added the int. In fact, let's try this and see. I'm going to say 4.5, enter. And okay. There is a bit of an issue right here. We do have an error message. Don't worry. I'm going to show you how we can handle errors in the next video, okay? But let me run this one once again, okay? And type in, let's say, 5, okay? Type in 5, type in 8, done. Okay, so it still works fine. So we made sure that we've assigned the numbers added by the user to the variable called num, and then we appended num to the numbers list using this particular function right here, numbers.append in num, okay? Now, because the user actually added some numbers, we wanted the program to check if any of those numbers were actually even. And by doing so, we had to create a loop that will run through all the numbers in the numbers list. And then if the number was divisible by 2 with no remainder, simply say, okay, we found the very first even number, print out that number. Otherwise, if the user did not add any even numbers, simply say no even numbers were entered by the user. And at the end of the day, simply print out the numbers that were added by the user. And if the user did not add any numbers, simply say no numbers were entered by the user. That's exactly what we did right here. So feel free to go through this program as many times as you need. Hopefully, it was relatively straightforward. And of course, as always, if you have any questions about anything we've done in here that you're not, you're not exactly sure, always feel free to reach out to me. I'll be more than happy to answer whatever questions that you have. So join me in the very next video where we'll now begin to take a look at how we can handle errors in our program.
Welcome to the brand new section where we're going to take a look at functions. And I guarantee you that no course on programming will be complete without talking about functions, okay? Functions are extremely important, and believe it or not, we've actually been working with some functions, and we've even created some of our own functions already in this course. You just don't know it yet. So in this section, we're going to focus on functions. I'm going to show you how you can create your own custom functions, and then how you can use something known as the parameters, okay? What do we want our function to work with? What kinds of data types, right? Things like that. We're also going to take a look at keyword arguments, local and global variables, and so much more. And just like with the previous sections, there's going to be a coding exercise at the end of the section, so please do attempt it. Hopefully you'll be able to pass. If not, don't worry, I'm going to provide you with the solution. So without wasting any more time, let's begin talking about functions. All right, so welcome to this brand new section where we're going to take a look at functions. All right, and so far so good. We've actually been working with quite a number of pre-built functions within Python. So functions like the print, input, range, and so on, they all perform a particular kind of operation. However, what if we wanted to create our very own custom functions? How can we do that? Well, to do so, we are going to have to define the name of the function first of all, and then decide whether or not that function is going to accept what we call parameters. And then we can also say, okay, this function will add these numbers, or it's going to do something. And then finally, we can choose to return a value within that function. So it's going to be something like this. Okay, you will have the to def, which is going to be the function to define the name of the function, and then we can choose to have parameters inside of that function. Okay, and then we'll have the function body. So add a plus b, add this, do this, divide this, check to see if this loop is true, stuff like that. Basically whatever the function will do. And then finally we can then choose to return a value, which, by the way, this is going to be optional. We don't always have to return a value whenever we are creating our own function. Let me give you a very, very basic example. So let's say, for example, we wanted to create a function that will print the words hello world. All right. We can say def, and then I can call my function greet. So the name of my function is going to be greet, and then I can add my brackets at the colon and then enter. By the way, notice that I haven't added any parameters inside of the brackets in here. Parameters are optional, okay? However, I'm going to come in right now and then define what the function will actually do. So I'm going to say print, and now I'm going to provide the words hello world. And now all I would have to do is to simply call the function. And how do I do that? I'm going to say greet and then the brackets, and there it is. So now if I was to run the program, there you go. It simply says hello world. So once again, we started off by giving the name greet to our function, and then we now told what the function should do. The function should print hello world whenever we call or use that function. And then right here, we simply call the function by simply saying greet and then in brackets, and there you go. So this right here is one of the most basic kinds of functions we can create. But that's it. Jump into the next video where we'll now begin to take a look at function parameters and arguments. I'll see you then. Welcome back. Now let's talk about parameters and arguments. See, a parameter is basically an input that we can add to a function in order to customize its behavior. In this case right now, in the previous example, the name of the function, which is greet, it didn't have any parameters at all. It's basically empty. That's why when we said, okay, print and then simply hello world, and then we call the function, all it simply did was just simply say hello world. But what if we now want to add a particular parameter inside? In this case right now, I'm going to come in here right now and say name. Okay, so the parameter right here is called name, and now I want my function to say hello and then the name that will be provided. So I'm going to come over here right now. Let's use the F string. And now I'm going to add my curly brackets rather, and call it name. Okay. So now check this out. When I'm calling my function right now, I can add what we call the argument. When you're passing a value to the function, it's going to become an argument. Please note the difference between parameters and arguments. Up here, when we're first defining the function, we're going to use the parameter. The parameter is basically us saying, hey, we're providing you with this input, and I'm going to use this input to customize how you, the function greet, will behave. However, once the function has been created, we've told what the function is supposed to do. In this case right now, hello, and then name the parameter. When we call that function, when we want to provide a value, it's going to become what we call an argument. So in this case right now, if I wanted to greet, let's say Alice, for example, right? Alice right now is the argument, and if I was to run the program, there you go. It says hello Alice. What if I wanted to greet, let's say Bob, right? Bob, let's go ahead and run the program, and there it is, hello Bob. These are parameters and arguments. However, we can also have multiple parameters in our function. So far right now, we've only been working with one single parameter, which is name. What if we wanted to create a function that will add two numbers together? How are we going to do that? Well, we can start off by defining the function name. So I'm going to call this one add numbers. Add numbers will be the name of the function. And now inside, we're going to provide two parameters, which are going to be A and B, colon. Okay. Now, return A plus B. We haven't talked about the return function or return statement yet. What return does here is that it's simply going to return the value of a particular operation. In this case right now, it's going to return the values of A and B when they are added together. That's what the return does. So now I'm going to come in here and say result. Okay, result is going to be equal to add numbers. Okay, and now inside I can add the two numbers I want to add. Let's say 5 and 6. And now all I will have to do is to simply print the result. And there it is. If I run my function, there you go, 11. You see how this works? First of all, we created a function by using the defined function called add numbers. Okay, that's the name of our function. And then we said, okay, our function is going to receive two parameters, A and B. And now with the return, we're basically defining what the function is going to do. It's going to return the value of A plus B. Now, all we need to do is to create a variable that will store the value of our function. So now the variable here is called result, which is equal to add number, the name of the function we're calling right now, with the two values, which are 5 and 6. And now we simply printed out result, which is equal to 11. That's exactly how parameters, arguments, and the return function also works. By the way, before I round up the video, just a very quick word on the return statement. It's used for two main purposes, okay? The first purpose is typically to exit a function. So you can use it to stop function execution. Second is to return an actual value. So as an example, let me just show you real quick. If I said define and then greet, okay, let me add empty parameters in here. And I said print hello, and then I said return. All right, but then after return, on another line, I also say print, and then let's say, let me say my quotes, hello, Jack. You can even see right now that within Replit, it's the text itself is kind of faded out, meaning that Python will not execute this particular line. So if I was to run, you can see right now it does absolutely nothing at all, but that's because I haven't called the function yet. So let me come over here and say greets and then brackets, and there you go. So if I was to run the function right now, you can see all it says is going to be hello. Why? Because return right here signifies that, hey, stop the execution of the function. It shouldn't go beyond this particular line, and that's why we only have hello. However, if I was to remove the return statement and I run the program again, you can see right now it says hello and then hello Jack. So this is another use of the return statement. You can use it to stop function execution, or like I showed you earlier, you can use the return statement to return a particular value. Thank you for watching the video. I will see you in the next class. Welcome back. I want us to now talk about keyword arguments. All right. Python functions, they basically allow us to pass arguments using parameter names. Parameter names are what we refer to as keywords. They'll make our code more readable and flexible, especially when we're dealing with many parameters. Now, so far, we've been dealing with parameters like A, B, X, Y, but let me show you something else, okay? I'm going to create a new function, and let's call this function describe underscore person, okay? So this function is going to describe somebody's name, age, and let's say city, all right? So let me add the brackets in there, and now in here, we can add the keyword argument. So I'm going to say name, age, and then let's say city. Okay. And now for the actual function itself, oh, sorry, I forgot to add the colon. And now the actual function itself, what's it going to do? We want it to print, okay, John is 30 years old and lives in London, just as an example, right? So I'm going to say print brackets and now the F string, okay, and now quotes and now curly braces, name, space is, curly braces again. I will now call the age parameter, bracket years, old, and I'll let Python finish the rest for me. And there it is. So basically, the function will say, okay, Alex is 100 years old and lives in New York City, just as an example. So check this out. I'm going to call the function. So you can see right now, I'm going to call Alice. Thank you, Python, for providing this suggestion. So I'm going to say Alice is 25 years old and lives in New York. So if I run the function right now, you can see it says Alice is 25 years old and lives in New York. Pretty straightforward, right? However, check this out. I can also call the function by providing the values for the parameters themselves. Look at this, okay? I can say describe person, and now in brackets, instead of saying, okay, Alex, 30, London, instead I can say age equals to 30. And now comma, and then I can say the name equals Bob. City is San Francisco. Did you see what I did right now? Instead of providing the actual values for the arguments directly, I just said, hey, I'm going to pass the values into the keyword argument. So age will be 30, name is Bob, city is San Francisco. And of course, please pay attention to the fact that Bob and San Francisco are strings. That's why they have the double quotes, while 30 is an integer. It's not a string. That's why there are no quotes. So if I run the function, you can see right now it says Bob is 30 years old and lives in San Francisco, despite the fact that here age came first. We didn't say name equals Bob and then age or city. No, that's because Python is simply going to use what we have described in the actual function itself. It's not going to matter the order of the arguments. Python doesn't care about that. All Python cares about is, okay, you've given me the keyword arguments, fine, and now this is the order. It's going to look at the function that says, okay, print the name first, and then is age, years old, and then lives in city. So these are what we refer to as the keyword arguments. It's not likely we're going to work with them later on in this course, but nevertheless, this is something that you should at least be aware of when you're working with Python. So thank you for watching the video. I will see you in the next class. Welcome back. One last thing I want us to talk about before we round up the functions section will be the concept of variable scope. See, in Python, or in fact in any programming language, we have both local and global variables. Variables have the scope, which will determine where they can be accessed. Now, variables that are inside of a function will be local to that function, and you cannot access them outside of that function, while variables that are defined outside of any function are global. As an example, okay, x equals, let's say, 12. All right, this right here is what we refer to as a global variable. Why? Because it's on its own. It's not inside any function or any loop or any if else statement. It's on its own. It's just there, x equals 12. However, if I created my own function and I said define underscore modify variable brackets colon, and now I said x equals 3. The x right here will be what we call a local variable because it is inside of the function which is modify underscore variable. So the global variable of x is 12. The local variable of x is 3 because, again, this 3 right here, it's inside of the modify variable function. So let's take a look at this, okay? I'm going to tell my function to print out the value of x, okay? And now I'm going to call the function modify variable. What do you think the value of x here is going to be? The value of x here is going to be 3 because we're simply calling the function modify variable, which already has the value of x to be equal to 3. So if I run my function, you can see it's right there, 3. But what if I wanted to call the global variable x equals 12? I want to print out that value. All I need to do is just to call the default print command or print function for Python and then simply say print x. Now, if I run the program again, now you can see 3 and now 12. Again, because this print right here, it's not the same print that's under the modify variable function. This print right here is meant to produce or print out the value of x, which is the local value that's inside of the function modify variable. However, this print x right here, notice again the indentation. It is not inside of this function, it's outside. So the x here is going to be the one that belongs to the global variable, which is 12. That is the difference between global variables and local variables. If you wanted to get this particular value of x, which is 3, you will need to always call the function that houses or that holds that particular value, which is of course modify variable. But the global variable, you can access it anywhere as long as it's not inside of the function. However, we can actually modify the value of our global variables inside of a function. Yes, we can do that. Check this out, okay? I'm going to go back to my function in here, all right? And just underneath, I'm going to say global x. Just by using this statement called global, we can modify the global value of x. So now I'm saying global x, x equals 3. In this case right now, we are simply modifying the global variable. That's what we're doing right now. We're simply going to modify the global variable of x. So now, if I run my program, you can see right now that first of all, the function modify variable x equals 3 will produce 3. And because we have now modified the global variable of x to now be 3 instead of 12, even when I call the print function that is outside of the modify variable function, it's still going to produce 3 because, again, inside of this function, we modified the global variable x. We changed the value from 12 to 3 by using the keyword global right here. So this is how you can also modify the global variables inside of a local function. Thank you so much for watching the video. I will see you in the next class. So welcome to the data structures section, and in here we're going to focus on three main types of data structures. We're going to talk about lists, dictionaries, and sets. And of course, I'm going to highlight to you the differences between these three. So you're going to learn exactly what makes a list different from a dictionary. You're going to learn exactly what a set is. And then once you've learned how to create your own sets and dictionaries and lists, we're going to learn how to incorporate loops into them. So say, for example, you have a list of passwords and you wanted a loop to go through each password and do something. You're going to learn how to do something similar in this particular section. And of course, there's going to be a wide variety of different coding exercises, so please do attempt them. There are also going to be 2 programming challenges, which of course I'm going to walk you through on how to solve them. And of course, just like with every other section, at the end, we are going to have the main coding exercise, which I want you to attempt. So please make sure you do so. Without wasting any more time, let's jump right in. All right, so let's begin by talking about lists. Now, lists aren't anything new to us. We've actually worked with quite a few lists already. We've had lists of names, lists of cars, and so on. But the one thing about lists is that they are what we call mutable, meaning that the items or elements that you have in a list, we can actually modify them, right? So we can add to the list, we can remove from the list, and we can modify whatever elements that already exist within that particular list. Now, over here, I do have a list of compromised passwords. So, the usual password, 12345, QWLTY, and so on. Now, I want to show you a few things that we can do in here, all right? I can say print, okay? And now in brackets, I can call the list compromised passwords, and now I can provide the index number of the item that I want to list. In this case right now, it is index number 0. If I run my program, you can see that's going to be password. So the first thing I want you to understand is that the items in a list, they all have index numbers starting from 0. So if I was to print index number 2, what do you think the answer would be? Yep, it's going to be QWERTY. Okay, that's the first thing I want you to understand. Next is the fact that we can perform various types of functions on our list. For example, I can say, let me call the list again, and now I can add this function here called append. Append right here in technical terms is what we refer to as a method. Methods are also functions, but there are very special kinds of functions. We'll talk about methods a bit later, but for now, just understand that we do have very special functions that we call methods that you can apply directly onto lists, and they will do something. So right now, what append would do is that it will add whatever new item we want into our list. So as an example, I can open up my brackets, and let's say we add swordfish. Okay, this is another very, very popular password used by a lot of people. Okay, so I've appended swordfish to the list. So if I go back right now and I print my compromised passwords, you can see swordfish has been added to the list. So this is the very first method or function I want you to understand that you can use with your lists. The next one is going to be what we call the extend function. See, with append, you can add, individual items, elements, and so on. With extend, you can actually add all elements from another list. So as an example, I have my first list right there, compromised passwords, and let's say we've created another list of compromised passwords. Okay, equals, and now let me open up the brackets in here, and let's add some fresh batch of passwords. Let's see, we have, what are the very common passwords people often use? Okay, let's say 1, 2, 3, A, B, C. How about that? And let me add one more. And let's call that one dog, cat, bone. just something, all right? Okay, so we now have two different lists, all right? One for the compromised passwords and then another for the new compromised passwords. So check this out, okay? I can come here right now and say compromised passwords and now extend. And now in brackets, I can say new underscore compromised password. So basically, I am attaching the new passwords into the old passwords list. And now if I run my program, now you can see that 123 ABC and dog cat bone have been added to my compromised passwords list. Now, another method I want you to be aware of is going to be quite the opposite of append, which is going to be remove. So let me first of all cut out our first or our second list rather. And I am going to modify this line right here and then say remove. And now in brackets, just as an example, okay, I can provide what I want to remove, which is 1, 2, 3, 4, 5. So let's say I wanted to remove this particular element. Very, very easy. I'll just say .remove, run, and now you can see that 1, 2, 3, 4, 5 is no longer in the compromised passwords list. So very, very straightforward. Another one we can do is to simply clear. We can clear the entire list as an example. So if I was to come over here right now, change remove to clear. All right, I don't need to have anything inside the brackets. So just clear. And if I run, there you go. It is going to be empty. There is nothing inside of the list anymore. So there's quite a few other methods that you can work with. I think it's about 11 of them, but let me give you 2 more. All right. Another one we can use is going to be reverse. All right. So basically what this will simply do is that it will reverse the items in the list. The order is going to reverse the order. So if I run this, there you go. It starts from let me in and goes backwards all the way to password. And then one more that I want to show you that can be very useful would be the copy method. So as an example over here, let me just come right here and I'll create a backup. Okay, so backup and let's say underscore accounts. Okay, I can assign the backup to my variable backup accounts and I can now say equals and now compromised passwords and now dot copy and now in brackets. All right, so basically what I'm doing right now is I would like to make a backup of this list, this compromised password list, and then assign that to the variable backup accounts. So now if I was to print the backup accounts and I run, you will see right now that we have the exact same list, the exact same item. So this is what you would use to create backups or copy the items in a particular list. So like I said, you do have a few other ones like sort, pop, and so on. We're going to talk about methods a bit later in the course. But for now, that's the introduction to lists and the methods that you can use to work with them. Thank you for watching. I will see you in the next class. So let's continue working with our lists, and I want us to try to write a program that will simply print out the high activity days. Now, what you see on my screen is a list of login attempts per day. So let us write a program that will go through this list and then print out the high activity days. However, to determine what a high activity would be, let's say login attempts that are 10 or more. Okay, so to do this, let's create a variable that will store the high activity days. So I can say high and then underscore activity underscore days. Okay, and now this is going to be equal to, let's say, attempts. Okay, we want to create a for loop that's going to go through the list. Okay, so we have our brackets in here, and then I can say attempt. Okay, for, remember, now for attempt in where are we checking the number of attempts? It's going to be in the login attempts list. So I'm going to say in the login attempts. And now we haven't talked about this yet, but you can also include an if statement directly inside of a for loop. So we want to create a loop that's going to go through our list, and then if the attempt is 10 or more, we're going to print out a high activity day. So attempt for attempt in login attempts. And now if what the attempt is greater than or equal to 10. You got that? Okay. So now what should happen? Let's simply print, and then in brackets, we can say something like high activity days, colon, and then comma, high underscore activity days. So now if I run the program, and there you go, the high activity days, we have 10, 12, 15, and 20. So this is how we can run a for loop to go through our list and then print or do something else. So I'm going to provide you with an exercise, a challenge in the very next video. Please go through it and attempt to answer the questions. Thank you for watching the video. I will see you in the next class. Let's talk about dictionaries. And just like with lists, you can modify, you can add, remove elements in your dictionaries. However, the core difference between your lists and your dictionaries is that unlike in your list where you have individual elements or values or items, in your dictionary, we're going to have what we refer to as a key value pair. So as an example, I can have a dictionary called user info and now equals, and I'm going to now use the curly braces. Okay, we typically use the curly braces for dictionaries. So in here, I can have information like the username, which would be admin. So right here, username is going to be the key, while admin is going to be the value of the key. We can also have our password, okay? And let's say the password here is let me in, just as an example. And we could even have another one, like let's say last login. Okay, last login, colon, and I can have a date, let's say 2024-10-22, just as an example, all right? So do note that whenever you're adding your key value pairs in your dictionary, at the end of each line, you will have the comma, but then for the very last key value pair, there is no need to add the comma at the end, all right? So just take note of that. So this is what we refer to as a dictionary, all right? We have our key value pairs, username, the value is admin, we have the key password, the value is let me in, and of course we have the key last login, and then we have the date there as the value. So from here, I could decide to print out the information. I could come down here and then say print. And now if I wanted to print, let's say the username, I will first start by saying user underscore info. And now the regular brackets in here, I would simply say user name, and that's it. So now if I was to run, you can see admin has been provided. So this is how you can print out the values of the keys in your dictionary. You simply state the key whose value you want to print, and the program will do the rest. So now, just like I said with dictionaries, you can easily add or modify the elements in your dictionary. So for example, if I wanted to add some new information, like let's say the email of the user, all I will need to do right now is I can come down here and simply say user underscore info. Okay, and now I will have the regular brackets, and now I'll simply add the key here, which is going to be email. And then very simply, I'm just going to say equals, and now I can add the email address right there. So let's just say admin at labcyber.com. All right, just as an example, all right? So if I was to come down in here right now and print the user info, let me just remove the key there. So we want to print out all the users' information in here. I run the program, and there it is. It's going to print out everything. So username is admin, the password is let me in, the last login is this date, and then the email right there is admin@labcyber.com. We could also update, all right? We could also update the information in our dictionary. So once again, as an example, if I wanted to update, let's say the password, right? So I can say user_info, and now in brackets, of course, the key here is going to be password, right? So password. And now I need to provide the new password. So let's call it swordfish. Swordfish. And there it is. If I run my program, now you can see that the password has indeed changed to swordfish. So just like with your lists, you can add new key value pairs to your dictionary. You can also modify the values of existing keys. Also, just like with lists, we do have a variety of methods that we can actually apply onto our dictionary. So the very first one here I want to talk about here is going to be the get method, which will retrieve the value associated with a key. So, for example, let me remove all this information in here. All right. If I wanted to print the user info, or what I get the username, the value of the key username, all I'll need to do right here is I can say print user.info and then .get. All right. And now in brackets again, I will now add the key, which is username. So this right here should print out the username. If I run, there it is, admin. So just like with your list that we used append, copy, and so on, we have the exact same methods also for dictionary, and get right here is one of them. Another method is going to be the keys, where you can simply print out all the keys that we have in the dictionary. So let me remove all the information in here. So if I run, there you go. We have all the keys, which are username, password, and last log in. We also have the opposite, which would be values. So instead of keys, I'm going to change this one over here to values. And if I run, now we're going to have all the values listed in the output. Now we could also create a loop that will go through our dictionary. And how can we do this? Well, we can use the for loop because we have a dictionary. Remember that the for loops work well with lists, dictionaries, and so on. So I'm going to say for, and now I'll have to say key. Okay, so for key, and then comma, value in, and now user underscore info, and we have to add another method called items. Items, and now brackets, colon, and there it is. This is how you would create your loop that will run through your dictionary. So it's going to say for key, comma, value, and then in the name of your dictionary, and then you're going to add the items method to it. And now all we have to do from here is to simply print out the information. So I'm going to say print, and let's use the F string. So regular brackets first, and now the F string, and now quotes, curly braces to hold and display the key. And now we'll have our colon, and now the other curly braces to hold what? To hold the value. And now if I run, there you go. Username admin, password let me in, and of course the last login date right there. So you can also use loops to run through your dictionaries, your lists, and so on. So that's it for dictionaries. Join me in the next video where we'll now take a look at what we refer to as nested dictionaries. I'll see you then. Welcome back. So in the previous lesson, we talked about dictionaries, but now we're going to go a step further to talk about nested dictionaries. So basically, dictionaries inside of another dictionary. So far, we've been dealing with one single user's info, but what if we had multiple users, right? How can we create this? So what I'm going to do right here is let's change the name from user info to user credentials. All right. This is going to be the new name for our dictionary. And now curly braces, we can now add the very first nested dictionary that will contain the information for admin. So I'm going to come right here, type in admin. That'll be our first user. And now the credentials, curly braces, let's go with password. Password in here, and then colon. And then we can go with admin 123. All right. So the first user here, admin, the password is going to be admin 123. And we can add another credential, which would be the last log in. So last log in. Let's have this one in quotes. Last log in. And now colon. Let's add the dates. So let's say something like 2024-10-19. All right. Just as an example. There is a bit of an error right here. Let me see what exactly am I doing wrong. Over here with password, the colon should be outside. I made a mistake there. Okay, much better. So this is the first nested dictionary. We have admin that has the key value pairs. It has the key password, and the value for password here is going to be admin 123. And then the other key here is going to be last login, and the value is of course 2024-10-19. But we can add another dictionary. So I'm going to say comma, and now we can add another user. Let's call this person user 1, and I'm just going to let Replit do the rest, fill out all the information in there. And there you go. So the password is going to be user 1123, and then last login is also. Now let's change the date here to something else. So let's go with 06, and then maybe 14. All right, just for variety. And there it is. So this right here is what we refer to as a nested dictionary. Dictionaries inside of another dictionary. And of course, we can access the information pretty straightforward. So for example, if I wanted to print out the password for the admin, how can I do this? Okay, I can simply say print, and now in brackets, I'm going to say user underscore credentials. Okay, and now the regular brackets, and inside double quotes, I'm going to say admin. Okay, and now we want to print out what the password for the admin. So brackets again. Let's add password. And there it is. So if I run the program right now, you can see it says admin 123 because we're saying, hey, print out from the user credentials dictionary. We want you to print out the value of the key password belonging to the user admin. And that's why we have admin 123. Or I could say, okay, print in brackets user credentials, and let's print out the last login for user 1. How are we going to do this? Again, very straightforward. I'm simply going to come in here, say user 1, and now new brackets, and then simply put in the last login key, last underscore login, and there you go. So I run. And there you go, 2024-06-14. So this right here is an example of nested dictionaries. And this can be particularly useful if you're trying to create functions or programs for firewalls, or a password checking tool, or a tool that will check user credentials, things like that, right? You can use nested dictionaries for those kinds of programs. So thank you for watching, and of course, I will see you in the next class. Let's continue with our data structures, and the next is going to be what we call sets. Now on my screen right here, it appears that I have two different lists that are similar in the elements inside of them. However, notice that the compromised passwords uses the regular brackets, while the new compromised passwords uses the curly braces. Now, believe it or not, this is extremely important because the regular brackets indicate that these items are in a list, while the curly braces will indicate that the items are not in a list but inside of a set. So the natural question right now would be, well, what is the difference between a list and a set? There's quite a few of them. The thing is, with your items in a list, you can order them. You can reference them using an index number, while in a set, they are not in any particular order. They are unordered, right? In fact, let me prove this to you. If I was to print right now the compromised passwords, all right, and then I also print out the new compromised passwords, look at the order. For the actual list, you can see it follows the same order: password 1234 QWERTY. But with the set, it's almost kind of random. It started off at 1234, then went to ABC123, it went to monkey, and so on. So the thing is, with sets, the items are not in any particular kind of order. Another major difference is that your list will allow duplicates, right? So, for example, I could add in my list 1, 2, 3, 4 again. However, if I was to do the same in my set, you will notice the difference. So if I run again, you can see right now in the list 1, 2, 3, 4 is repeated, while in the set 1, 2, 3, 4 is listed only once. It is not allowed. You're not allowed to have duplicates in your sets. And this is why whenever you're trying to create a function or a program involving like a list of items that should be unique, like let's say passwords or email addresses or user accounts, you want to use sets for those as opposed to lists, because you know that, okay, no two users can have the exact same credentials, so it'd be more ideal to use a set. So sets are typically a lot faster to run through. The program can run through a set a lot faster than it would a list. Now, both are mutable. Your lists and your sets are mutable, meaning that you can make changes, you can add elements, remove elements, you can modify them, and that's pretty much it. But just like with your lists, we also have operations or methods that we can use on our sets. We actually call them mathematical operations, like union, intersection, difference. Let me just show you, okay? Let me remove this right here. And now, let me come over here and let's work with our two different sets. Okay, I don't think I need this line anymore, actually. Okay. So right here we have set 1, we have set 2, and then both have two IP addresses. Now, I could decide to find IP addresses that are common in both sets, right? So I could say, for example, common underscore IPs would now be equal to set 1, and now union. Okay, so intersection, all right? Intersection. And now set 2. So intersection right here is what we refer to as a operator that will find the common elements in both sets. So if I was to come over here right now and then say print common IPs and I run, you will see 10.0.0.1 is common in both. That's why it is printed out. But we also have what we call the union mathematical operator. So I can change the symbol right here to the union symbol. What this will do, it's kind of like the extend method for lists, where you'll add the elements in one list onto another. So right now, if I run, you can see we now have all the IP addresses. However, take note that again, because this is a set, the 10.0.0.1 IP that's present in both will only be listed once. All right. We have another operator in here, which will be the difference operator. Just use the minus sign. Now, what this will do is that it will find elements that are present in one set but not in the other. So if I run this right now, you can see that 192.168.1.01 is an element that is present in the first set but is absent in the second set. So we can do the opposite. Okay, I can say set 2 minus set 1, and now this will give us the 192.168.1.102, which is of course present in set 2 but not present in set 1. We also have methods like your add, remove, clear. So as an example, if I wanted to add a new IP address to set 1, all I would need to do here is I will just say set 1 and now dot add, and now in brackets I can add the new IP address. So I can say 192.168.0.10. All right, just as an example. So now if I was to print out set 1, run, and there you go. You can see right now that 192.168.0.10 has in fact been added to our set 1. You can also have other methods like remove, clear, and so on. Feel free to look this up in the Python website if you wanted to. So that's it for sets. Thank you for watching. I will see you in the next class. Welcome back. Now I want to walk you through an exercise that has 2 tasks. And on my screen, you can see we have a dictionary of different logs. You can see the key value pairs there, the username, and then the IPs, and then the statuses, right? So the 2 tasks are as follows. First of all, we want to identify and print out all the unique IP addresses in the logs. And then second is to look for a special IP address that might exist. If it exists, then we're going to print out something. If it doesn't exist, we can print out something else. So you're more than welcome to pause the video and actually attempt to solve these 2 tasks on your own. One hint I will give is that we're definitely going to have to work with some sort of a for loop that's going to go through each log and then specially look for the value of the IP addresses. And we're going to have to pass the results into a set. Because remember that with sets, we're not going to have any duplicates. And since we're looking for unique IP addresses, sets would be the ideal way to go. So you can pause the video and try it on your own. If not, I'm going to walk you through on how we can solve both tasks. So first of all, task 1, we need to identify all the unique IP addresses. So one thing we could do right now is we could simply create a set that's going to store these unique IP addresses. And I'm going to call that set unique IPs. Okay. And now what I'm going to do is, because it's a set, I'm going to open up my curly braces. But now think about it, okay? We want to go through each log and then look for the value of the IP key. So check this out, okay? I'm going to say log, and now I'm going to open up my brackets because we want to target what? The key, which is IP. So essentially we're saying, okay, for each log, let's access the IP. And now I'm going to introduce my for loop by saying for log in logs. All right. So what we've done right now is we've created the for loop that will go through each log in our logs dictionary and will specifically look for the value of the IP key. So since we've passed everything into a set, all we need to do right now is just to simply print, and then in brackets we can say something like unique IP addresses colon, and then simply add a comma, and now unique underscore IPs. And there it is. I'm pretty sure you might have expected that this will take a few more lines of code. So congratulations if you were able to solve this on your own, regardless of whether or not it was 2 lines or 3 lines or 4 lines or 5 lines, because there are other ways how we could solve the task, but this is easily the shortest and the most effective way. So let me go ahead and run the program right now just to make sure it works. And there you go. Awesome. So we have everything in there: 192.168.1.1, 1.5, 1.2, 1.4, and then 1.3. Awesome. Cool. All right. Next is going to be task 2. Okay. So what are we looking for in here? We're looking for a special IP that's equal to 192.168.1.4. So we can say special IP equals 192.168.1.4. So what are we going to do right now? We'll have to use the if-else statement, because we're saying, okay, if this special IP address was found in this, do this, else do something else. So I'm going to say if special underscore IP in what? In where? In our unique set. Unique IPs rather. Unique underscore IPs. What do we want it to do? We want it to say print, and then we can say, special IP address was found. Okay. Else, oops, sorry about that. And then we can say else print, and then special IP address was not found. And there you go. Okay, let's go ahead, run the program, and there it is. The special IP address was indeed found. Now if I change 4 here to, let's say, 10, just to make sure that it's actually working, and I run the program again, there you go, special IP address was not found. So once again, congratulations if you were able to solve either tasks or both tasks on your own. If not, don't worry, it's all part of the learning process. But I'm going to give you an exercise right now that you'll have to attempt on your own. So I will see you in the next class. Welcome back. So I have decided to add one more task to make it the 3rd task. And it's going to be a bit more complicated. And this task is going to involve counting the number of failed login attempts per user. So essentially, we're going to go through each log, count the number of times a particular user failed in their status, and then simply print out Alice has, 4 failures, Bob has 1 failure, and so on, something like that. So you're more than welcome to pause the video and attempt to solve this task on your own. If not, let's go through this together. So like I said earlier, I have my notepad file in here because I want us to tackle this logically. Okay, so let's go step by step. The very first question here is this: are we going to be dealing with a set, a dictionary, or a list? Let's think about it, right? Obviously, it cannot be a set because sets do not accept duplicates. So if we're going to use a set in here and Bob had 1 failed login attempt, the second time Bob has a failed attempt, the set will not accept it because remember, sets do not accept duplicates. So sets will not work here. It cannot be a list either because think about it, okay? We need to associate the username with the number of times they have failed. And it's dictionaries that are great for working with key value pairs. So the key here will be the username, and then the value is going to be the number of times that particular username has failed in their status. So we're going to be working with a dictionary. So we need dictionary to store username and their respective failed login attempts, right? Okay, now what do we need to do to actually find out the number of times each user has failed? We need to create a for loop. So for loop to go through each log, right? And then when it goes through a log, what are we looking for exactly? We want to look for the status that says failure. We're not interested in the success. We're interested in the failure. So we can say if the status, so if status equals to failure, what do we want to do? We want to identify the username associated with that failure. So let us extract the username. Okay, we're going to extract the username and then we can store that in a variable called, let's say, username, right? So we can store the usernames in the variable username. So once that username has been found, let me correct this one, extract. Okay, so once a username has been found to have a status of failure, there are two possible scenarios here. Think about it, okay? It's either this is the very first time that username has had a failed login attempt, or it could be the second time or third time or fourth time. Essentially, it could be it's not the first time. Okay, so we need to create conditions for both of them. So we can say if it's the first time, okay, we can say, all right, the username here, the score is 0 because it's the first time, okay? However, if it's not the first time, we need to add 1, okay? And then also add it to their previous record. So if it's the very first time, you start off from 0, you get 1. But if it's not the first time, if it's the second time or third time, we're going to simply add 1 to your previous record. I hope that makes sense. And then finally, we can simply print the failed login attempts. Okay, so you can pause the video again and try to solve this task on your own. If not, let's write the program together. Okay, so what are we doing first of all? We are creating our dictionary. So I'm going to call the dictionary failed attempts. Okay, equals, and then curly braces is going to be empty because nothing is in there for now. So next is going to come the for loop. So I'm going to say for log in logs colon. And now what are we looking for? We're looking to check to see if the username has the status of failure. So specifically, we're looking to check if the status is a failure. So I'm going to say if log, and now we want to target the status, right? So if the status in here is equal, oops, sorry about that. This should have been outside. So if status is equal to what? To failure, capital F. If it's equal to failure, what are we looking for? We want to extract the username. So I'm going to say username will be equal to, and now let's extract the name. I'm going to say log, and now in brackets, user name. Let me add the quotes right there. And there you go. Okay, so what have we done so far? First of all, we've created the dictionary failed attempts. Now we've created our for loop to go through each log in the logs and then look for any log whose status is equal to failure. When you find that status that's equal to failure, let us extract the username and then assign it to the variable username. Now remember, there's going to be two conditions. Is this the first time this username has the status of failure, or is it not the first time? So check this out. I'm going to say if username, okay, is not, how do we check if it's the first time? If it's not in the failed attempts. Okay, so we're saying if this is the first time that we're actually discovering that this user has a failed record, so we can check that by saying username is not in the failed attempts. What do we want to do? We want to say failed attempts, and now in brackets, username is going to be equal to 0. However, if it's, oh, sorry about that. Let me see, failed attempts. Actually, I do apologize. I've made a mistake with the attempts. There should be a T for the S. I do apologize. Let me add my T there and add my T there. Okay. So, however, if it's not the first time, if it's the second time, third time, what are we doing? We are saying failed attempts. And now username is going to be equal plus equal to 1. Because we're going to be incrementing their values. So if it was 1 before, now it's going to become 2. If it was 2 before, now it's going to become 3, and so on. I want to point out the fact that notice the second failed attempts here, it's outside, it's not inside this if statement, okay? Because this right here, lines 21, 22, is just to check to see if the username did not exist previously. And now the second failed attempts here, this is to check to see if indeed the failed attempt has already been recorded previously, and now we're incrementing by 1. So all we need to do right now is to print, okay, and then make sure this is outside. Print, and now in brackets we can say something like failed login attempts per user, and then colon, and then we can simply now add failed underscore attempts, and there you go. Okay, so hopefully this should work. I'm gonna run the program, and there you go. Awesome. So Bob was 3, Alice was 2, and Dave was 1. I think this is correct. Bob has 1 here, 1, that's 3. Okay, Alice was successful here. Okay, this is a failure 2. Okay, and then Dave is 1, and of course Carol did not show up because Carol had only 1 log and she was successful. So that's pretty much it on solving this particular task. So once again, we created our dictionary called failed attempts. We created our loop to go through each log and then say, okay, if we do find a status that's failure, we want to check, first of all, want to extract the username associated with that failure, and then check to see if the username has been in our failed attempts previously, or if it's the first time. If it's the first time, I assign them the value of 0. And then if it's not the first time, simply add 1 to their previous value. By the way, a confusion you might be having here is, wait, hold on, Alex. Why is it that here on line 21, 22, if it's the first time that their record is a failure, that the username has a record of failure, why not say equals to 1? Why 0? The reason is because on line 23, we, regardless, are going to add 1 to their value, whether or not it's the first time or it's the second time, so it doesn't even matter. I hope you get what I'm saying, right? Because this is going to go, so if it's the very first time, right, first of all, the program will say, okay, your failed number of attempts is 0 on line 22, and then on line 23, it's going to add 1 regardless. That's why we assigned 0 in here and not 1. If we assigned 1 here, then automatically, whoever had just 1 failed attempt will now have 2 against their record. And to prove it to you, you can see right now Dave has just 1 failed login attempt, right? If I came here right now and I change 0 to 1 instead, and I run the program, look at that. Dave now has 2. That's why we made this one 0 first. Because we know that on line 23, on the very next step, 1 will be added to that user's record regardless of whether or not it's their first time or their second time. So hopefully you understand what we did there. Thank you for watching, and of course I will see you in the next class. Alright, so welcome to the programming challenge where we are going to create for ourselves a very basic authentication system. We're going to apply everything we've learned so far, from variables to functions to loops, and of course most recently dictionaries. Alright, now I have already written out the program. This is the output. Okay, so the way the program is going to work is like this. At the very beginning, the user will be presented with three options to either register, log in, or simply exit the program. Now, if they say 3, it will immediately exit the program and will end the entire authentication system. However, if they were to go with 1 and they press enter, now they'll be asked to provide a username. I'm going to go with John. Let me provide my password as password. And there you go. Registration will be successful. Now, if I was to go and type in 1 again, and I tried using the exact same username, John, to create a new account, the system will check to see that, oh, John already exists. Try a different username. So our program is going to check to see if the username already exists. Now, for number 2, if we try logging in, it's going to ask for the username. Now, if I say John, all right, and then I provide the right password, you can see right now it's going to say login successful, welcome back. Now, if I tried logging in again with the exact same username, John, but this time I used the obviously wrong password, it's going to say invalid username or password, please try again. So this is going to be our basic authentication system. This is how it is going to work. And what I want to do right now is to bring over my notepad file in here just to kind of give you an idea of what we're going to be working with. So obviously we're going to need a dictionary that will store the user credentials, because we're going to have to compare and see if the new username that the user wants to input has already been created before, if the password is correct, things like that. And we're going to be using a dictionary because we'll have to create the pair, the key value pair, username and password, where username will be the key and then the value of the key will be the password. So dictionaries are going to be useful here. We're going to need 2 different functions. The very first function will be to register the user, and then the other will be to log in the user. Now, for the actual function to register the user, what do we need? First of all, we are going to have to ask the user to provide their username, and then we'll have to have some sort of an if-else statement that will check to see if the username already exists. If it does, ask for another username. However, if it's a brand new username, then the program can proceed to ask for the password. Once the user has provided both username and password, we will then have to create the username password key value pair. I'm going to show you how exactly to do this. Once this is done, we can then say that the registration has been successful. So pretty straightforward. For the function to log in the existing user, again, we will have to ask the user to provide their username and password. And then we would have to check to see if the username matches the password that's already been stored in the dictionary. If it's false, then we're going to print invalid username or password. Otherwise, if it's true, if the password and username match, then we can say login successful. And then finally, the third stage will be to create the actual authentication system, where the user will be presented with 3 options to either register, login, or quit. And depending on which option the user chooses, we would have to call the relevant function. So we're going to build this authentication system from the ground up. Are you excited? I hope you are. Let's jump right in. So the first thing we're going to do will be to create the function that will register the user. However, let us create our dictionary that will be used to store the user credentials. So for the dictionary, we can call it user underscore credentials. All right, equals, and then we're going to have our curly braces. All right.
Now for the actual function to register our user. In fact, let me just add the note there real quick. So function to register user. Okay. Let's define the function. So I'm going to go def and then let's say register underscore user. Okay. Colon. Now, what do we need? First of all, we need to ask the user to input their username. And we can assign that to a variable. Let's call that variable username equals. And now let us prompt the user to provide the username. So input, and then we can say enter your username. Okay, just as an example. Let's press enter. And let me leave some space in here between the colon and the quotes right there to have some spacing. So right now, we need to check to see if the username that the user provides actually already exists. So let me just add a note in here on a separate line. Let's add the note. Check to see if username already exists. Okay, so how are we going to do this? Well, we can do so by using the if statement. So I'm going to say if username, and now in the user credentials, again, Python has already given us the code. So if username in the user credentials, colon, let us print username already exists. Please choose a different username. I think I like this. However, I'm going to remove the return. We don't need that. So, however, if the username doesn't exist, if it's a brand new username, we can then add our else. What else do we now need to do? We need to ask the user for their password, right? So I'm going to say else. Let us create a variable password and then assign that to the input, and then in brackets, let's say enter a password, colon, and then let's add the closing quote, and there it is. Okay, so from here right now, the next step that we'll have to do is to create the key value pair for username and password. Now, how are we going to do this? Well, we're going to do so by calling the dictionary user credentials. Okay, and now check this out. I'm going to open up my brackets and I'm going to provide the key, which will be username, and now equals to password. This is how we can create the key value pair. You provide the name of your dictionary, and then in brackets, you provide the name of the key equals to its value. And there it is right there. And then the final step will now be to simply print registration successful. And there it is. Okay? Now, let us try something. I am going to call this function, and let's see if it actually works. I'm going to say register user, brackets, colon, and there it is. Okay, let us try this. Oh, sorry, we don't need colons in here. I do apologize. We don't need colons right there. Let's run the program. All right, enter username. I'm going to say John. Let's enter a password. Let's just say John, okay, for the password. John. Enter once again, and it says registration successful. Okay. However, notice that the program has ended, and that's because we don't have an actual loop that will continually run to keep asking the user to provide a new username, a new password. So what can we do to run this program indefinitely? Well, we can introduce the while true loop. So over here, just underneath the register user function, I am now going to call in our loop that says while and then true. However, indentation is going to be very, very important. So I am going to tab all of this to make sure that everything falls under the while true statement or loop. Let me add my colon right there. And there it is. Now we're going to have the program running continuously. And let's check to see if it will actually check if the username we provide already exists. So let's run the program again. All right, so this time I'm going to go with Mark. Password is password. Okay, fine. Registration successful. Now you can see it's asking for another username. Let's try Nancy. Password, let's go with swordfish. Okay, it's working. Now, let us try using Mark again. Enter. And now it says, username already exists. Please choose a different username. So awesome. We can see right now that the first part of our program, the one that checks to see if, or the one that registers the user and checks to see if the username already exists. You can see right now that it's working perfectly fine, and that is awesome. So join me in the next video where we're now going to move on to stage 2, where we're going to create the function to log in the user. Welcome back. Now let's move on to the second stage where we're going to create our function to log in an existing user. What I'm going to do is I'm going to push the function here all the way down to the very end. And outside, let's add our new note that says function to log in the user. So what do we need? Let us first of all create the name of the function. That will be def, let's say login underscore user. And let's add a colon. So what are we going to need? We're going to need both the username and the password. So let us say username equals, and now input, we're going to prompt the user to provide their username. So enter your username. Okay, colon, let's add some space right there. Okay, next will be the password, right? So I'm going to say password equals, and then enter your password. Pretty straightforward. We're going to have to now check to see if the username actually matches the password that we had in the registration section. So I'm going to add my note real quick. Check to see if username and password match. Okay, so how do we do this? The good old if, and now username in user underscore credential. Oops, sorry about that. In user, so if username in user credentials, and because both username and password have to be checked, and user underscore credentials, and now the brackets, username equals to the password. All right. So you see what we did here? We're checking to make sure that if the username that's already been stored in the dictionary user credentials, and now the key value pair for the username and password, if they actually match, then we can print. All right, I'm going to say print. Let's just say welcome back. All right, very, very, very simple. Else, if it's not a match, we can print. Now we can say invalid username or password. Please try again. All right. And there it is. Pretty straightforward. So what I'll do right now is I am going to call both of the functions, register user, and then also login underscore user. However, we need to pay very close attention to the fact that the loop currently resides inside of the register function. It is not outside. So we need to run our loop independently of the register function and the login function. So what I'll do is I am going to cut out the while true, cut it out, okay, and then I am going to paste it outside on its own while true. However, everything else must fall under it. So I'm going to tabulate everything under. Let me do this again. And there you go. So there it is. So you can see right now that the user credentials and then the while loop are outside, they're independent. Now, the while true, the entire loop begins with registering the user and then logging in the user, checking to see if there are matches, things like that. So this should work. I'm going to go ahead right now to run the program and let us see. So I'm going to provide the first username. Let's go with Mark, and then password will be admin. Registration successful. Now let us try to log in as Mark. So I'm going to say Mark and then admin. Sorry, Mark and then admin. And there you go. Welcome back. It worked successfully. Now it's gone back to the registration phase. If I try to now create another account with Mark, it's going to say username already exists. Please choose a different username. Let's go with Nancy. Okay, password for Nancy. Let's go with password. Okay, and now you can see it says, sorry, invalid username or password, please try again. The reason why this happens is because the way the program is written out right now, it simply goes step by step by step by step, regardless of whether or not the previous step was successful. So over here, you can see it started off with the registration phase. That worked. It then moved on to the login phase. That worked. It now came over here for the login phase again. For the registration phase again. It saw that Mac already exists as a user. So it said, please choose a different username. However, it skipped asking the user to create another username. Over here, it went straight to the login phase where it checked to see if Nancy existed. Nancy did not exist. That's why it said invalid username or password, please try again. So right now, it has gone back to the registration phase. So if I say Nancy again, now you can see it's asking Nancy for the password because it's in registration phase. Now if I type in admin, it says registration successful. Now let us try logging in because now it has gone to the login phase. I say Nancy. Nancy's password is admin, but I'm going to type in something different. Enter. And then it says invalid username or password, please try again. So we can see right now that the program works kind of like 80%. The registration phase and login phase work. However, if we were to, ideally, when we're trying to create a new user account, and if we are trying to use a username that already exists, the program should not move on to the second stage, which is to log in the user until the user has actually provided a brand new username for the registration. We're going to fix that in the third and final part of this assignment. Welcome to the final part of our assignment, and that is to now create the actual authentication system that will prompt the user to either register, log in, or maybe just even exit the system. Now, what I'm going to do first of all is I'm going to remove the functions in here, register and log in, and I'm also going to remove the while loop right here because we're going to run that in a different location. And now I am going to change the indentation and make sure that the functions register user and login user are on the same line. This right here should be under the login user function, and there it is. Okay, so let us begin by creating the authentication system. So I'm going to add my notes and call this one the main menu. Okay, and now we can define our function in here, authentication underscore system. Okay. And there it is. All right, so what do we need here? We need to prompt the user to either register, log in, or exit. So we're going to print out a couple of statements. Okay, so let us begin by printing out, and I'm going to say, let's say basic authentication system. Okay, this will be at the very top. And then next, let us print out the very first option for the user. So we can say one.register will be the first option. Okay, and then print option number 2. So this will be 2.login. Okay, and then the final option in here would be 3, and then dot, let's call that one exit. Okay, and there it is. So we've got our 3 options in here. Now, the user will have to add either 1, 2, or 3. So let us create a variable that would represent that particular option. So I'm going to call this one option. Okay, so option is going to be equal to input. And now let us ask the user, enter your choice. Okay, so we're asking the user right now, hey, provide us with what you want to do. So we're going to have to create the if, else if scenario where we'll check to see if the user chooses option 1, which is register. We can call the register user function. If they choose option 2, we can call the login user function, or if they exit, we can simply end the loop. So I am going to say right now that if option right here equals, and now I can say 1, colon. What do we do if the user chooses option 1? Well, we can call the function register underscore user. Okay, very, very straightforward. Now, else if, which is going to be if it was option 2, what are we going to do? We are going to call the function login underscore user. And now for the last one, if option equals 3, what do? We can print, and then in quotes we can say exiting the system. Okay, and there it is. And then we can say else if the user maybe provides option 4, 5, 6, which don't exist, then we can say else print, and then in brackets we can say invalid choice, and then we can say please choose from options 1, 2, or 3. And there it is. And there it is. And now finally, we can run the authentication system. And we can do this by simply saying authentication system. And there it is. So there is one thing that we haven't added just yet. I don't know if you can spot what it is, but that is the loop. Because right now, as it is, this program will run just once, but we want the user to keep on either logging in or registering or exiting. So what do? This is where we'll have to call in the while true loop. But where do you think we're going to put it? We are going to put it just underneath our authentication system function. Okay, so here is where I'm going to say while true. And now remember, everything in here will have to fall under the while true statement. So make sure your indentation is correct. And then we're going to have to add the break statement as well to end the loop. Now, where are we going to end the loop? We'll end the loop where the user chooses option 3, which is to exit the system. So just underneath in here, underneath print, I'm going to say break, and there it is. Our program hopefully should work without any issues. Let me go ahead right now and run it. And okay, so we do have an issue right here, and that's because the break is outside the loop, and look at that. Oh wow, indentation is so important. You can see right now that if all of this is in the same indentation as the while statement. So yeah, let us go back over here and indent them properly, and there it is. As you can see, even I make mistakes with my indentation as well. So let's make sure that everything else is indented properly. Okay, all right, let's try running the program one more time. Okay, thankfully it works now. So let us test it out. Okay, so I'm going to go with option number 1. First of all, let us register Mark, and his password is admin. Awesome. Now let us try going to option number 2 to log in. Okay, so username, let's try Nancy as an example. Password, let's say Bob. But now it says invalid name, username or password, please try again. So it's obviously working really well. So let's try again to register, this time as Mark once again, and check to see if the program will detect that Mark already exists. So Mark, and it says, okay, username already exists. Please choose a different username. Okay, let us try logging in this time as Mark. Okay, and let us provide the password, which is admin, and it says, welcome back. It actually worked. Let us try logging in again as Mark, but this time let us use a different password, a wrong password, and then it says, invalid username or password, please try again. So it appears it is working properly. The final test is to exit, enter, and there you go. Exiting the system, the loop has ended, the program has ended. So there it is. We have successfully created our program, which is a basic authentication system that would allow a user to either register, log in, or simply exit the program. And of course, we've added checks to ensure that no duplicate accounts can be registered. We've also added checks to ensure that the usernames and passwords will match. And there it is. Congratulations. I hope you enjoyed this assignment, this challenge. Thank you for watching. I will see you in the next class.
Well, there you have it. We've come to the end of today's mega tutorial where I've shown you how to code with Python with a special emphasis on cybersecurity. From the bottom of my heart, thank you so much for making it this far. If you enjoyed the tutorial, please be sure to give it a thumbs up. Share this tutorial with anyone whom you feel might benefit from it. And of course, if you have any questions, comments, put them down in the comment section below. I'll do my best to answer them as soon as I possibly can. Again, if you're interested in the main course, if you enjoyed this tutorial and you feel, you know what, Alex, I like the mini tutorial, I want to go for the main course itself, I'll have all the links for you. Again, special discount, only $19.99 for the first 100 students who sign up for the course. So once again, it's been a pleasure teaching you how to code with Python. If you're new here to the channel, welcome. Please be sure to subscribe and hit the bell so that you're notified whenever I upload a new tutorial. Stay safe out there, and I'll see you next time. Cheers.